Okay, the rate of change is nothing, right? So change means what? Let's say change means what? Think about before a year ago, before 1 year ago, right? Maybe your weight is 50 kilograms, right? Now you measure the weight, you have 60 kilograms, right? So the change is what? So what is the change? 60 minus 50, right? Did you get my point? So just imagine into last year, to 2023 January or January, your weight is 50 kg, right? January 1st, 2024, January 1st, the same time you have measured the weight, you have 60 kilograms, right? So the change is what? Change is what? Your weight change 60 minus 50, right? How long? The year, 1 year, right? So that is the change, right? So similarly, we are find out the changes in different functions, right? So functions mean the relation between the variable, right? So in this example, right, what will happen? This is a function. This function explains how the variables are changed. So this function says how the manufacturing cost will be changed depending on the number of units you are manufacturer, right? So let's say if you are manufacturer, if you manufacture, uh, okay, you are manufacture 100 units. So how about the cost? So C of 100 is the cost. If you manufacture 101 units, your manufacturing cost is 101, C of 101, right? Now the rate of change means C of 101 minus cost of 101 minus cost of 100, then divided by number of units you manufacture, right? Early, now you are manufacturing 101 units minus in the early stage you are manufacturing 100 units. So that is a change. You need to put both variables, right? So this one is called average rate of change, right? That is nothing, right? Okay. Now we will look at derivatives. So derivatives in the sense, derivatives means there is a very small amount of change in a variable, that is we can call derivatives, right? Just imagine you have a function f of x, right? You have a function f of x, right? So it means, just think about, you have a function y is equal to, right, x cube plus 2x or 5 or something, right? It means this is the relation between the variable x and y, right? Now what will happen if you do a small change, that is derivatives. Derivatives means if you do a small change, small increment or decrement on the variable x, that is we can call derivate. Small change in a variable we can call that is a derivate value, right? Now if I increase the x value by delta x, because of that increment delta x, my variable, the value, the function of y also increase, right? So delta y is a derivative. Delta y is the increment of y. So if your previous example, if you look at the previous example, right? If I increase the del x by 1 unit, so that is a 1 unit means the delta x, the increment of x, the increment of number of units I manufacture. Because of that increment of number of units I manufacture, what will happen? There is a increment or decrement happen in my manufacturing costs. If you notice here, right, 54 minus 45. So now what will happen? If I manufacture 5 units of chair, manufacturing cost will be 54 rupees, right? If I manufacture, sorry, 45 rupees, if I manufacture 5 chairs, the manufacturing cost will be 5 chairs, the manufacturing cost will be 54 rupees. If I manufacture 4 chairs, the manufacturing cost will be 45 rupees, right? So now what will happen? If I increase by 1 unit, so just here in the function, if I increase by 1 unit, what will happen? There is an increment happen on the cost as well, right? That is we can call change, right? So similarly, what will happen? If I do an increment of my variable x, because of that increment in my variable y also, they have a small increment or decrement. We don't know what will happen, right? If you do a change on this variable x, the small change we are mentioned as a delta x, right? This is a small change. Because of that, we are mentioned as a delta x. So because of that delta x, we have a small change in our variable delta y also, right? So the differentiation means, right? Let's say this is your function, right? If you find out delta y over delta x, that is in the limit x approaches, limit, right here. Okay. So the differentiation means limit delta x approaches zero, right? Delta x close to zero, right? Delta y over delta x, that is we can call differentiation, right? Don't think too much, right? If you find out the average rate of change, if x approaches zero, that is differentiation, right? We can define this differentiation f of days x, right? If I write f of days x in anywhere, you can understand this is a differentiation, right? Or maybe you can write dy over dx. This is also different ways we can indicate for differentiation, right? Maybe I can put y dash, or maybe I can put f of dash x, right? Maybe I can put f of dash, right? These are the different uh, symbols we can use to indicate the differentiation. So dy over dx and f dash x, these are the mostly used to symbols, right? So if I write dy over dx means, what is that? The average rate of change between y and x, right? If I do a small change in the variable x, how the variable y will be changed, that average rate of change we can call dy over dx, right? You don't need to worry about these things, right? Just understand the average rate of change if x delta x approaches zero, that is differentiation, right? Just remember the equation is this one. So this is the equation for differentiation, right? So what is the equation? The limit delta x approaches zero, delta y over delta x, it is equal to f of x naught plus delta x minus f of x over delta x. So this is the equation for differentiation, right? So how we are getting this equation? Tell me. I already get this equation, right? So now look at here. Now just look at here. Y is equal to f of x, right? Now my x value is equal to, initial x value is equal to, x is equal to x naught, right? So at that time, what will happen? F of x naught is equal to something, right? F of x naught. Now what will happen if I increase x by delta x value? So this is my initial x value, x naught. Now if I do a small increment on x, that is delta x, then my y value becomes, right? Now my y value becomes here f naught. Here my y value become f, sorry, here f of x naught. Here y value become x naught plus delta x, right? So you already know change means what? Delta y over delta x is the change, right? If I do a small change in x, so the change in y. So delta y means what? So the new y value, this value, new y value means f of x naught plus delta x minus f of x naught. So this is the change happen in my variable y, right? Over, so the delta x means that is delta x, right? That is that value, delta x value, I can do the change, increase. So because of that delta x change, this is the change happen in my function, right? So if I put limit, then that is the differentiation, right? Okay, you can easily understand if I explain with an example, right? So yesterday we look at, to find out the limit value, right? We need to analyze, we need to study the graph, both side of the equation, right? So that is a traditional way. need to analyze, right? Similarly, here to find out the differentiation, right? To find out the differentiation, we are using first order principle, right? To find out the differentiation, to find out the differentiation, we use first order principle. We can call as a first order principle. We can say this one as a first order principle, right? I will tell you what is that first order principle, right? So first order principle means, okay, now I will explain with this example, right? So already you know, right? Differentiation means limit delta x approaches zero, f of x plus delta x minus f of x over delta x. This is differentiation, right? So this equation is we are getting from this first order principle, right? So every time you apply the first order principle to get the changes, the differentiation, right? Now just imagine you have a function, right? So the function is f of x is equal to 3x squared plus 2x. Just imagine this is your function. F of x is equal to 3x squared plus 2x, right? So now this is something a relation, right? So they have some variable x. So this variable x will have a relation with this function, right? Let's say now x is something, right? Just think about x is a length of something, right? So that length of something is changed with this function, right? Now what I am doing here, I am increase a delta x for x, right? Now, now the x value is x, no? So now if I increase x value by x plus delta x, right? So now what time happen? I can now the initial stage x value is x. Now I can increase the x value by delta x, right? So this is my initial value x. If I increase the x by delta x, definitely what will happen? My by the f of x will be changed, right? So now tell me what is f of y? So what is f of y? F of x. Now tell me what is f of x? Now the length is x. Okay, just think about the length is x means my f of x is equal to what? 3x squared plus 2x, right? Now I need to find out if my x will be increased by delta x, what is my f of x? So how you can find out? Just you can replace x by x plus delta x in this function. That is my f of x plus delta x, right? It means, let's say now x is my length, right? Now if I increase the length by delta x centimeter, maybe delta x is a 1 centimeter, right? Previously x is a 10 centimeter in our previous example, 10 centimeter. Now I have increased by 1 centimeter means 10 plus 1 now 11 centimeter, right? So now in this equation, I need to replace x by x plus delta x. So for x, all x, I need to replace x plus delta x to the power 2 plus 2 into x plus delta x, right? New, this is my new f of x, right? Maybe in the previous example, right? This is number of units. So this is cost of manufacturing, right? So this is my manufacturing cost if I manufacture X units, right? So the meaning of this one, what is that in the previous example? Manufacturing cost for manufacture X units of chair, right? So this is what manufacturing cost for manufacture X plus delta X units of chair, right? If I manufacture X plus delta X units of chair, this is my manufacturing cost, right? So now tell me, so we need to find out the difference. So difference means what? I need to find out delta, sorry, or maybe I'm used the similar delta y over delta x. So delta y means what? F of x plus delta x minus f of x. This is delta y, right? This is the change. So this is the cost change for manufacturing X unit and X plus delta X units. So X plus, you need to subtract X plus delta X units cost minus the cost of X units, right? Over, so you did the change, right? So the new distance, the new value is what? So the new value is X plus delta X minus your your earlier X is X, right? Now we can write dy over dx is equal to, now you can replace for this one in this equation this, right? So what is this? 3 into, okay, I'm writing in the next line. Okay, I'm right on this line, right? What will happen? Delta y. So delta y over delta x is equal to, right? So tell me, 3 into x plus delta x to the power 2 plus 2 into x plus delta x, right? Over, you can cut x and x, delta x, right? Now, I already told you if it is a differentiation, I need to take limit both sides. Limit delta x approaches 0. So dy over dx. Here also I need to take limit both sides. Delta x approaches 0. Right? So now for this one I need to take 3 into x plus delta x whole thing to the power of 2 plus 2x plus 2 delta x over delta x. Okay. Now we know, right? If you have this f of x plus g of x, so we can separately take the limit, right? Before I can take the separate limit, right? First I can take the long form. So a plus b whole thing to the power of 2. So I can write a squared plus 2ab plus b squared. So just look at here. This delta x is not equal to delta plus x. Just remember, right? So delta y similarly is not equal to delta plus y, right? That's a one word. Delta y or delta x is a one word, one symbol. Don't think this is delta plus y, right? That's important. Okay. Okay. Now plus 2x. Sorry, here minus is there, right? So minus. So here what will happen? So just look at here, f of x plus delta x minus f of x. This is subtraction, right? So minus 2x minus 2 into delta x. So here I can write minus 2x minus 2 delta x divided by delta x. So now I can simplify. Limit x delta x approaches 0. 3x squared plus 6x into delta x plus, because 3 into 2, 6x into delta x, 3 into delta x whole thing to the power of 2 minus 2x minus 2 delta x over delta x. Okay. The next step, just look at here. So for this one, we can write, right? So this one is dy over, so here delta x is there, right? So delta y over delta x, delta y over delta x means that is a dy over dx, that's a differentiation. Dy over dx is equal to, now we can filter, right? Now we can write limit x approaches, delta x approaches 0, 3x squared minus 2x plus, so if you look at here, this one, this one, this one, right? what will happen? We can take delta x as a common, right? If I take delta x as a common, here delta x is there. Here I can write 6x plus 6s plus 3 into delta x. Okay, the remaining things minus 2 over delta x, right? Now for this one, I can separately take the limit delta x approaches 0. Oh, yeah, just wait. I did a small mistake, right? So the equation is correct. Yeah, I did a mistake, right? No one can notice. Okay, yeah, I will explain again, right? That's the only way. I think the space is not enough. Okay, just look at here. Yeah, it's very difficult, right? Yeah. Mm, okay. I think up to this level you can understand, right? F of x plus delta x minus f of x. It's you can understand, right? That's the rate of change, right? So now what will happen? This is my equation, right? F of x is equal to 3x squared plus 2x is my function, right? Now what will happen? If I do a small change, in the x value, because of that, my f of x also will change, right? So if I do this is initial x value. If I increase by delta x, because of that, my f of x will be changed. So this is my initial f of x value. This is my new f of x value, right? So this change happened because of increasing the value x from x plus delta x, right? Because of increasing the value x plus delta x, the function changed from this one to this one. Do you agree with me? So now we know, okay, now we know, right? I will delete this one. Now just look at here. We know delta y over delta x is the rate of change, right? That rate of change, right? That is equal to what? That is equal to what? F of x plus delta x minus f of x over over delta x, right? So delta x means maybe you can directly write rather than this one. So your new for this f of x plus delta x, your x value is x plus delta x. New x value is x plus delta x minus x. That is the delta. If you cut this one and this one, we are directly put delta x, right? So now tell me what is f of x plus delta x? You can replace this, right? So what is this value? 3 into x plus delta x whole thing to the power of 2 plus 2 into x plus delta x, right? This is your f of x plus delta x minus your f of x is this one. What is this? Minus 3x squared plus 2x, right? Now what I need to do over x, sorry, over delta x, right? X and x we can cut down. The remaining part is delta x. So this is what? Delta y over delta x. This is delta y over delta x. Now what we'll do, just we can write in the form. This is a plus b whole thing to the power of 2. We can write this one x squared plus 2x into delta x, 2x into delta x plus delta x whole thing square, right? So this is one word, right? Not think delta into x. Delta x is a one word, right? Don't confuse, right? So this is the form of this one, a plus b whole thing to the power of 2 plus 2 into x plus 2 delta x minus 3x squared minus 3x squared. If I remove the bracket by minus 2x over delta x. So this is delta y over delta x. This is the rate of change, right? Okay, now just look at here. If I remove the bracket, 3x squared plus 6x into delta x plus 3 into delta x whole thing to the power of 2 plus 2x plus 2 into delta x minus 3x squared minus 2x over delta x. Right now I can cut down 3x squared, 3x squared, 2x, 2x. So the remaining part is 6x into delta x plus 3 into delta x holding to the power of 2 plus 2 into delta x over delta x. Up to now, did you clear? Did you clear this level? There is nothing, right? Just I can simplify the equation, right? Please turn on your mic, right? 017, turn on your mic. Sorry, turn off your mic, right? 017, 017. Okay. So up to this, I think you can clear, right? Just nothing, I can simplify the equation, right? Now, we know if it is a differentiation, we need to take limit both side with delta x, right? So now I am taking limit x delta x approaches 0, delta y over delta x. That is the differentiation, right? So if I do a thing, I can take all sides of my equation, right? If I take the limit both side, I need to take the limits, right? So that's why I'm taking limit for both side. So my next side, okay, now if you look at here, in all the elements, there is a delta x is common, right? So I can cut this delta x, this delta x. So better way, right? From here, I am taking delta x as a common, right? So if I take delta x as a common, 6x plus 3 into delta x plus 2 over delta x. Now I can cut this delta x and delta x. Now the remaining element is 6x plus 3 into delta x plus 2. So this is my remaining part, right? Now then I am taking the limit, right? Now it's easy for you, right? Now just look at here. Now this is the thing, right? Now if now I know delta y over delta x is equal to 6x plus 2 plus 3 into delta x, right? This is the remaining things, just nothing. I can take delta both side and cut down, right? I will take common as a delta and cut down, right? Now I can take limit delta x approaches 0. Delta y over delta x is equal to, I need to take limit both sides. So delta x is equal to 0. Then 6x plus 2 plus 3 into delta x, right? So now we know this is equal to dy over dx, dy over dx, this one, right? That's in differentiation, right? Now we know if we have a function like this way, we can take limit separately. Limit delta x approaches 0, 6x plus 2 plus limit delta x approaches 2, 2. Then I can take limit separately, f of x plus g of x in the form, right? Limit delta x approaches 0, 3 into delta x, right? I can write 3, then delta x is my variable. So I can write 3 into limit delta x approaches 0, delta x, right? So this is what we are discussed yesterday, right? So if you have put limit, you can, this is in the form of k into x, right? So the constant value I can write in the front, right? So that's why I'm writing 3 here, right? Now I can replace delta x by 0. There is no delta x here, right? Here there is no delta x here. So I can directly write 6x, right? Plus here, what is the value for this one? Limit delta x approaches 2, limit delta x approaches 0. For the function is 2. So that is a constant function, right? It always take the value of 2 plus 3 into limit delta x approaches 0, delta x. Now tell me, what is the value for this one? What is the value for this one? Based on the yesterday's class. 6x plus 2 plus here 3 multiple by delta x approaches 0. So this value is what? This is my function. This function is what? Tell me. So what is the answer for this limit? Tell me. Hello. What is the answer for that one? Anyone?
Zero, sir.
Yeah, very good. Yeah, 0, right? So for this value, we can replace based on the limit theorem what we have discussed, 0. So dy over dx is equal to 6x plus 2. This is altogether 0, right? So if we differentiate this function, so what is the function is? Function is, the function is this one, right? So the function f of x is equal to 3x squared plus 2x. If I differentiate, I can write dy over dx, right? Dy over dx is equal to 6x plus 2, right? This is we can call differentiate by using first order principle, right? Right? So f of x is equal to 2x squared plus the function is 3x squared plus 2x, right? 3x squared 3x squared plus 2x. If you have a function, right, if you differentiate dy over dx is equal to 6x plus 2, right? Or maybe we can write f of dash x equal to 6x plus 2, right? So we can use different notations to indicate differentiation. So maybe you can use f of dash x or dy over dx. So this is the value for if I differentiate 6x plus 2, right? Will you notice here, you need to do so many steps to find out the differentiation, right? It's a very difficult task, right? You need to write a lot of lines, right? Okay, now I am giving you another example. Just try yourself, right? Just try to find out the differentiation equation with the help of first order principle, right? Right? F of x is equal to 4x squared plus 3x, right? Okay, now I need to find out dy over dx, or maybe we can call f. I need to find out the f of dash x. Can you try this? So the same principle you can apply, first order principle, and find out the answer f of x. Can you find out? Can you find out what is dy over dx? Just apply the same principle by applying the previous example. First try yourself and tell me the answer. I'm giving you 5 minutes time. So what is the first step? So it means if I need to find out the differentiation means, right? I need to find out limit x delta x approaches 0. Right? Why I'm telling delta x approaches 0? I am compare with very small value for x, right? So now just think about, right? So based on the definition of limits, right? So dy over dx is equal to limit delta x approaches 0, f of x plus delta x minus f of x over delta x, right? This is the definition, right? So you need to remember this definition. Limit delta x approaches 0, f of x plus delta x minus f of x over delta x. Definitely you have a question on that in your final exam, right? I clearly mentioned, right? Find out the differentiation dy over dx by using first order principle, right? If I ask you to answer by using first order principle, definitely you need to do this way, right? After this one, I will give a very shortcut way, right? I previous case in the limits also, we need to write a lot of lines, right? Lot of big table and find out the limit value. Then we find out some set of rules. By using that set of rules, we can easily get the answers for limits, right? Similarly here, the first order principle is very, very difficult, right? You need to write a lot of lines, but you can easily find out by using some set of rules. You can easily find out the answer for differentiation, right? I also teach you those things, but if I ask you to write the answer by using first order principle, definitely you need to use the first order principle only, right? So this is a definition. Limit delta x approaches 0, f of x plus delta x minus f of x over delta x is the equation, right? Now for this equation, I need f of x plus delta x and f of x, right? So now I know f of x is what, right? So if I have x is my variable, right? F of x equal to, right? F of x is equal to 4x squared plus 3x, right? Now I need to find out if x is equal to x plus delta x. Now I need to find out f of x plus delta x is what, right? Now f of x plus delta x is, so just nothing, right? In your function for x, you can replace with x plus delta x, right? So here 4 into x plus delta x whole thing to the power of 2 plus 3 into x plus delta x, right? Just you can replace for x by delta x. There is nothing, right? This is my f of x plus delta x, right? Now just nothing, I can just directly replace here, right? So if I replace here, limit delta x approaches 0. So f of x plus delta x, I can put 4 into x plus delta x whole thing to the power of 2 plus 3 into x plus delta x. Yeah, I'm explaining, right? Yeah, I'm explaining. Just look at here, right? This is a function, right? Differentiation means we need to find out the rate of change, right? Average rate of change. So this is function means they have some relation between the variable x and y, right? Depending on the variable x, the values are changed. Yeah, wait, the answer, right? It's wrong. 11x plus 3 is wrong answer. You did some mistakes. Maybe 3 is correct, but you have a mistake on 11x. Just check that one, right? So just look at here, right? The definition is this one, right? Limit x delta x approaches 0, f of x plus delta x minus f of x over delta x. It means nothing. You need to find out what is the value. If I increase the value by delta x, what is the value for my function f of x plus delta x, right? So previously we will find out f of 3 and f of 2, right? So then we can write f of 3 minus f of 2, right? This is the f of x plus delta x minus f of x. So similarly here, what I'm doing here, my x plus delta x minus f of x. That's the same thing, right? So now I need to find out what is f of x plus delta x. So f of x plus delta x means for in the f of x, I need to replace for x by x plus delta x. So now for each x, I can replace by x plus delta x. 4 into x plus delta x whole thing to the power of 2 plus 3 into x plus delta x minus, here f of x is there. So what is my f of x? 4x squared plus 3x, right? This is my f of x over delta x, right? Now just nothing, just you can limit delta x approaches 0, 4 into x squared plus 2 into x into delta x plus, sorry, plus delta x whole thing to the power of 2 2 plus 3x plus 3 delta x minus 4x squared minus 3x over, here there is a 4, right? 4 is there, so I can remove by bracket 4 here. Here it is come 8. Here 4 will come, right? For lines, we to more than to save the time, right? I am directly remove the bracket, right? So here a plus b whole thing to the power of 2. Then I can write x squared plus 2x into delta x plus delta x to the power 2. Then I can multiple by 4 each element. So 4x squared, uh, 4 into 2, 8x into delta x plus 4 delta x to the power of 2, 3x, 3 delta x minus 4x squared. Then Yeah, then minus 3x over delta x, right? Now I can remove minus 4x plus 4x, right? 3x, 3x. So the remaining part, limit delta x approaches 0, right? 8x plus 4 delta x, right? Then the remaining part is 3. So I'm taking delta x as a common, right? Over delta x, right? Here delta x is there. Here delta x to the power 2 is there. Then if I take 1 delta x as a common, 1 delta x comes here, right? So if you remove this, for 8x into delta x, 4 into delta x to the power of 2, then 3 into delta x, right? Now I can cut delta x and delta x. So why I am cutting delta x and delta x? Delta x is not equal to 0, right? Here I am telling that delta x approaches 0. So approaching 0, delta x approaching 0 means that is not meaning delta x is equal to 0, right? Just clearly understand, right? Delta x approaching 0, close to 0, not 0. That's why I can cut, because I can't cut both sides by 0, right? 0 by 0. So now what will happen? So now just what will happen? Limit delta x approaches 0, 8x plus limit delta x approaches 0, 4 plus, sorry, 4 in, sorry, here what will happen? 4 into delta x, here limit delta x approaches 0, 3, right? Now you know how to find out the limit values for these. Right, tell me what is the limit value for this 8x. So 8x I can write this way, right? So I can put 8 here, then only x is there. So 8 into, here delta x is equal to 0, right? Not x is equal to 0. So it will come as a 8x, right? So here it will come as a 8x plus, here what will happen? 4 is there, delta limit delta x approaches 0. So delta x becomes 0. So 4 into 0 plus, here, this is a constant function, always take the value of 3, right? Whatever the value it will take, the value delta x takes, it takes the value of 3. So now, what is the answer? 8x plus 3, right? So if anyone get this answer, 8x plus 3, someone tell 11x plus 3. I don't know what is the mistake you did, right? So just you need to clearly do the things, right? This is we can call differentiation, right? Yeah, it means I didn't get don't clear letters. Okay, then I can write let's see. The upcoming questions I try to write clearly, right? How about now? Is it okay? The letters are? Is it okay now? Tell me. Okay. So if you have an idea, right? So to find out a differentiation means you can find out the average rate of change between the variable, right? If you have a function, on that function you have a different variable, right? So the relation between the variable in a function is called the function, right? The functions mean the relations between the variables in the uh, in particular scenario, right? So whatever the real world scenario, we have different relations, right? So the relations between the variable we can define as a functions, right? So if you find out the rate of change, average rate of change in the function, that is we can call differentiation, right? So the differentiation means the process of finding derivatives. The derivatives mean the small changes in particular variable x, how the variable y also change. The average rate of change is called differentiation, right? So the rate of change we can call as a rate of change of one variable, right? How the another variable also change because of that variable x change, right? So this is the definition we already discussed, right? So we can define differentiation dy over dx. We can define differentiation dy over dx. Now it means limit delta x, right? Delta x means okay. Delta x means this one. This is delta, right? This is delta, or maybe you can use this delta, right? So limit delta x approaches zero. F of x plus delta x. Sorry, f of x plus delta x minus f of x over delta x, right? This is the function. So this is the definition of delta x, right? So whatever the function, if I give you a function, if I ask you to find out the differentiation from first order principle, then you can apply this rule and you can find out the answer, right? Okay, just they are explaining that already we discussed, right? So if you increase a small, just look at here. When the variable x is increased by a small delta x, the variable y will be increased by delta y. If you do a small increase on that variable x with delta x, definitely your value of y also will be increased, right? So now we can say initial y plus delta y. So that is equal to f of x plus delta x, right? Then this is the rate of change delta y over delta x, f of x plus delta x minus f of x over delta x, right? They are explaining the theory, right? Okay, now, okay, I'm giving you a function, right? I'm giving you a function f of x is equal to 3x, okay? F of x is equal to 3x. Can you find out f of dash x? I need the answer f of dash x. F of dash x means what? That is the differentiation, right? So how we can find out the differentiation? So f of dash x is equal to f of dash x is equal to can you follow with me? F of dash x is equal to limit delta x approaches zero, f of x plus delta x minus f of x, right? Over delta x. Right now, I need to replace limit delta x approaches zero, f of x plus delta x. So here for x, I need to replace with x plus delta x. So 3 into x plus delta x minus for f of x 3x over delta x, right? So now what will happen? Limit delta x approaches zero. So here 3x minus 3 into delta x, sorry, 3x plus 3 into delta x minus 3x over delta x. Now I can cut 3x and 3x, right? So the remaining part, limit delta x approaches zero, 3 into delta x over delta x. Now I can cut down delta x and delta x, right? So what is the remaining part? Limit delta x approaches zero, 3 is there. So what is the answer for this? 3, right? So the f of dash x is equal to 3. 3 is the answer, right? So if I am asking you to find out the answer with the help of first order principle, definitely you need to follow the steps to find out the answer, right? So here they are they are using different ways, right? Here they are using different ways, right? This is first order principle way, right? F of x plus delta x minus f of x over delta x, right? So here what they are doing, right? I will explain that one also, right? Y is equal to 3x. This is your function, right? We need dy over dx, right? We need dy over dx. Also, altogether, we have two ways to answer this question, right? Now, if I increase a small, just we need to write, right? I am doing a small increment delta x in, I am doing a small increment in delta x, doing a small increment in delta x, the y value increased by delta y, right? Now, you know, so if I increase the x value by delta x, so now what will happen? My x value becomes x plus delta x. My y value increased by delta y, no? So y plus delta y. So this is my first equation. This is my second equation. So I need what? I need delta y over delta x. I need delta y over delta x, right? So here, if you look at this is second equation, right? This is first equation, right? To get delta y, I need to subtract from second equation to first equation, right? So y plus delta y minus y is equal to 3x plus 3 into delta x minus 3x. Right now, y and y we can cut. So delta y is equal to 3x we can cut. So the remaining is 3 into delta x. Right. So now what will happen? If I divided by both side delta x, right? So this one we can remove. So delta delta y over delta x is equal to 3. So that is we can call differentiation, right? Both are correct, right? So better you can follow this principle, first order principle, and find out the answer. On that way, also you are doing the same thing, right? There is nothing. Okay. Up to now, we are discussed with first order principle, right? So definitely you have one question on your final exam. Find out the differentiation by using first order principle, right? So just practice how to find out the answer for by using the first order principle, right? Now we will look at that shortcut forms, right? Now we will look at what is the shortcut form. So shortcut form is nothing, right? Already the pupil find out some set of principles, set of rules, right? The mathematicians, they analyze those things and they will introduce some rules, right? Rules mean the same pattern we are discussing the limits, right? If you have this pattern, this is the answer for limit. If you have this pattern, this is the answer for this one. Similarly, here they are giving you some way the differentiation value. That is we can call set of rules in differentiation, right? Now we will look at. So how they will find out? Just look at here. This question, the function f of x is equal to 3x, right? The function f of x is equal to 3x. They are getting the answer f of dash x is equal to what? 3, right? If you notice here, this is we are getting the answer from first order principle, right? F of 3x means. Okay. Now, can someone tell me, do it yourself and tell me, let's say y is let's say f of x is equal to 7x. So can you find out the answer for f of dash x? So how you can find out? Limit delta x approaches 0, f of x plus delta x minus f of x over delta x, right? Then what we can write? 7x plus delta x minus 7x over delta x, right? Now what will happen? 7x plus 7 into delta x minus 7x over delta x. So 7x we can cut. So also delta x also we can cut. So the answer is 7, right? So now what will happen? Limit delta x approaches 0, 7. So the answer is 7. So now if you notice here, f of 7x, the differentiation value f of dash x is equal to 7, right? So previously it is 3. So if your function is f of x is equal to constant into x, then if I find out the f of dash x, that is the differentiation. So the differentiation is equal to k, right? That is one principle. That is a one rule, right? So if you remember this rule, you don't need to do again and again that first order principles and find out the differentiation. Directly by applying this rule, you can find out, right? So if you look at here, in the previous example, we will find out f of x is equal to 3x. So we will find out f of dash x or dy over dx is equal to 3, right? Similarly, for this one, we will find out, but here we will find out f of x is equal to 7x means f of dash x is equal to 7, right? So it means 7 and 3 are constants, right? So the common form f of x is equal to constant into x is a function. Then if I get the differentiation, that is k, right? I can omit the x, right? That is the one rule. They will find out, some mathematician prove that one, right? You don't need to do the first order principle each and every time, right? Just look at here. This is the first principle, right? Just imagine here u, v, y are functions, right? So just think about, previously we have a function y is equal to f of x, right? So this is a function. Similarly here u also a function, v also a function. They are telling they are also a functions, right? They are functions of x. So functions of x means y is equal to x squared plus 3 or something likewise, right? So it means that y is equal to x squared something means your dependent variable y is depend on the variable x, that is for each. So u is equal to x plus 3 means the function u depending on only x, right? So that is the they are mentioning throughout this sentence, right? Now they are telling k is a constant, right? Now this is a constant function rule. The first rule says, let's say you have a function y is equal to f of x, right? Let's say you have a function, the previous case, you have a function, maybe we can call function as a y, or maybe let's say you have a function y is equal to k. The first principle says, let's say you have a function k, then if I find out the differentiation dy over dx, that is equal to 0, right? So the meaning of this one, if I get the differentiation of a constant, maybe whatever the number, that is a 0, right? So that is the first principle, right? So let's say now maybe we know the function we can denote it by f of x as well, right? F of x is a function that is a k is a constant value, right? So k is a constant value. So the differentiation f of x is equal to 0, right? Both are correct, right? Maybe we can denote it by f of dash x or dy over dx. Both are correct, right? Any doubts in the first rule? Any doubts in the first rule? Tell me. Any doubts in the first rule? So if you have a function, right? If you have a function as a constant function, yeah, I will explain with the example. Yeah, you can find out, right? So y is equal to k means k is a constant value, right? So now I'm asking you if find out the differentiation of this function y with x. Sorry. Okay. So what I'm telling here, you have a function that is a constant function, right? Then if I find out the differentiation of that function, that is 0, right? So if I differentiate any constant value, it gets 0 as a differentiation, right? Okay. Now just look at here, right? I'm telling you a function f of x is equal to 8, right? Now just think about f of x is equal to 8. 8 is a function, right? Now, if I do a small change in the variable x by x plus delta x, now tell me what is my f of x plus delta x? That is also, so this is, if this is my function, What is f of x plus delta x? That is also 8, right? Because this is a constant function, right? We already discussed y-axis, x-axis. So this is the function, the parallel line for x-axis. That is f of x is equal to 8 means this is 8, right? So now just look at here. Okay, I will show you with first order principle. Right now, what will happen? First order principle says limit delta x approaches 0, f of x plus delta x minus f of x over delta x. Right. So now just replace f of x plus delta x is equal to 8 minus f of x also 8 over delta x. Now what will happen? 0 over delta x. Right. Now if I, so now what will happen? If I replace with 0, right, now I can write here limit delta x approaches 0, 0 divided by limit delta x approaches 0, delta x, right? So here 0, so it is a constant function, so 0, right, divided by delta x approaches 0 means that's 0, right? So the answer is 0. This is not 0 over 0, right? Okay, so now you are getting an answer as a 0, right? So if whatever the function, if it is a constant function, right? If you differentiate dy over dx is equal to 0, or maybe you can write f of dash x is equal to 0, right? This is the first rule in differentiation. So rather than you are applying the first order principle directly, you can write the answer, right? Okay, now tell me what is the answer for this one, right? Okay, you have a function f of x is equal to 4, right? Now I need to find out f of dash x. So what is f of dash x? So here 4 means 4 is equal to k, right? 4 is a constant, right? So if I differentiate a function with a constant, it is always 0, right? You don't need to apply the first order principle and find out the answer. If you look at anywhere, if while you are differentiate, just you can directly place f of dash x is equal to 0. Or maybe just think about y is equal to 25, right? This is a function, right? I need to find out dy over dx. So that is a differentiation. So dy over dx is equal to 0. So just remember, if you differentiate any constant value, always you get 0 as a differentiated value, right? If you differentiate any constant value, it is a 0. That is we can call as a constant function rule, right? That is the first principle you need to remember, right? So if you have any functions, if you differentiate, right, that function is a constant value, then it becomes 0, right? So if I ask you what is the value for, uh, let's say I'm telling you y is a function, right, 105. So what is the value for dy over dx? So it means what I'm telling here, you need to differentiate 105 by using x, variable x, right? So it means how the variable y will be changed with the change of x, right? It is equal to 0, right? If it is a constant function, whatever the value you can increase for x by delta x, always your function take 0, right? There is no change happen, right? That is a true, right? If you look at the diagram, this is a parallel line, right? Even whatever the delta x change you happen for your graph, there is no changes in your y value, right? So you just remember, if you differentiate any constant value, it takes 0, right? The differentiation of a constant value, it becomes 0, right? That is the first rules you need to remember. Okay, the second rule, linear function rule. Linear function rule means, what is the equation for linear function? Y is equal to mx plus c. This is the format for linear function, right? Let's say y is equal to 5x plus 3 or something. This is an example for equation for linear function, right? Now, if you have a function this way, y is equal to k is a constant into x plus 2 or something, whatever the number here. Now, if I ask you to differentiate, so dy over dx is equal to just k, right? just k. Just remember, right now tell me what is dy over dx for this equation. Dy over dx is equal to, for this equation, what is the value? Tell me. So if you remember the second principle, dy over dx is equal to what? So y is equal to 5x plus 3. So similarly, kx plus 2. Hmm? Yeah, very good. 5, right? So the differentiation value is 5, right? Now we are getting the same answer if I apply the first order principle, right? Limit delta x approaches 0. So f of x plus delta x. For f of x plus delta x, I can write 5 into x plus delta x. So then 3 minus 5x plus 3 over delta x. Now just look at here. Limit delta x approaches 0. 5x plus 5 into delta x plus 3 minus 5x minus 3. So 5x, 5x. Sorry, not this one, right? 5x, 5x plus 3 minus 3 over delta x, right? So now what will happen? Limit delta x approaches 0. We can cut delta x and delta x. 5 is there, right? Now what is the answer for this? 5, right? So that is we are getting directly without applying the first order principle, right? So the easiest way, first you can, if in the exam paper, if I ask you to apply the first order principle and find out the answer, first you can do the answer by applying these theorems, right? First you can apply the direct rule, set of differentiation rule, and find out the answer. Then you can do the first order principle and whether you can compare whether I can do this correct way or wrong. If you get the same answer in both, that is your first order principle is also correct, right? So these rules are defined on by applying first order principle, right? The mathematicians, they do the things and they will find out some common properties, right? So now actually what will happen? Y is equal to kx plus 2, right? Actually what will happen? If I differentiate dy over dx means I can differentiate kx, I can differentiate kx plus I can differentiate 2 into dx, right? So already we know if you have a constant function, the first rule says if I differentiate any constant value, it becomes 0, right? Now if you have a k into u, right, we can write this one. You can write k in front of the differentiation, dx over dx, right? Then what will happen? K dx over dx means 1 plus 0. So it is equal to k, right? That's why we are telling this, right? So the second rule says if you have a function in the linear form, right? Let's say now tell me y is equal to minus 4x plus 3. So what is dy over dx? Dy over dx is equal to what? Dy over dx is equal to minus 4, right? Only that constant value you need to take. That is a differentiation. This is we can call second principle linear function rule, right? Okay. Okay, now I will explain the third one. Okay. The third one, if you have a function, if you have a function y is equal to x to the power n, right? Right? If you have this type of things, if you differentiate dy over dx is equal to n into x to the power n minus 1, right? This is the equation, right? This is a rule, right? So what I'm doing here to find out the dy over dx, first I can write this power, right? The power in front of these, then I can write this function with already the power is n, then I can write n minus 1, right? Did you understand? Okay, now tell me, you have a function y is equal to x to the power 7. You have a function x to the power 7. What is the answer if I differentiate dy over dx? Tell me, what is the answer? Dy over dx? What is the answer? Tell me. So if you apply this principle and tell me, if you have a function y is equal to x to the power n, right? Then I can write n into x to the power n minus 1. Similarly here, x to the power 7, right? N is a number. So y is equal to x to the power 7 means, what is the answer for that? Tell me. What is the answer for that? What is the answer? Hello, are you in the session? Tell me the answer. Yeah, very good. So how I can write the answer? First, I can take this 7, 7 into x to the power 7 minus 1. There is nothing, right? So dy over dx. So if you remember this principle, 7 into x to the power 6. This is the answer, right? Okay, now tell me, uh, f of x is equal to 2x to the power 5. Okay, 2x to the power 5. Tell me what is f of dash x? F of dash x is equal to, okay, just remove this one. Tell me now. Okay, f of x is equal to x to the power 5. So I need to find out f of dash x. If you don't believe these rules, just you can apply the first order principle and check the answers, right? It's always correct, right? From this first order principle, they will get some decision, right? So now what will happen? 5 into x to the power 5 minus 1. So it is equal to 5 into x to the power 4, right? This is the answer, right? Yeah, very good. Okay, this is we can call power function rule, right? If you have a function f of x is equal to x to the power n, then we can write n into x to the power n minus 1, right? This is the principle. The next principle, right? You have a function on this way. You have a function y is equal to k into x to the power n, right? So if you have a function this way, if you differentiate this one, dy over dx is equal to, just you can put the constant, then n into, then just put the constant separately, multiple by, now you know how to differentiate x to the power n, n into x to the power n minus 1. So this is the answer, right? So if you look at here, if you have a function k, sorry, function y is equal to k is a constant into x to the power n. So dy over dx, so dy over dx means d into kx to the power n. So this is the internal meaning, right? So the y means this one, right? dy over dx. So k into x to the power n is equal to just k into n into x to the power n minus 1, right? This is the formula, right? Now tell me y is equal to 7x to the power 4. I need to find out dy over dx. Tell me. So just you can take the 7. So what is the answer for this one? 7 multiple by, tell me the answer. 4x to the power 3. So it means 4 into 7, 28x to the power 3. Yeah. Okay. Now tell me, I did a small change here, right? Now my function y is equal to 7t to the power 4. Right? Now 7t to the power 4. Now I need to find out dy over dt. Tell me the answer. Now, previously I differentiate by using the variable x, right? Now, my function is depending on t, variable t, right? Now, if I do a small change in my variable t, how my function will be changed, right? We cannot say always our functions are depending on the particular variable x, right? Maybe just imagine they are telling a function, right, with the time. Just imagine t is the time, right? So 7t to the power 4 is a function and any relations between the y and t. Now I need to find out differentiation mean I need to find out dy over dt. If I do a small change in my time, how my variable y will change, right? So that is dy over dt. So now tell me, just you can apply the same principle, right? So if you have a function with this form, k into constant into x to the power n, here constant into t to the power 4. So previously they are asking differentiate by based on x, dy over dx. Now we are asking dy over dt, right? So what is the answer for this? Tell me. Just nothing, right? Previously, we will find out the relations between y and x. Now we are find out the relation between y and t. If I do previously, we check if I do a small delta x increment in y, if I do a small delta x increment in x, how the y change. Now I am checking if I do a small delta t change in my t, how my y will change. There is nothing, right? We cannot always x, always we can change the value as well, right? So now tell me, what is the answer for this? Dy over dt. So this is a constant, right? I can write the constant separately. Then 4 into t to the power 3. So the same answer, 28 t to the power 3. Previously 28 8 to the power 3 because of we have the delta dy over dx here, dy over dt. Because of that we are putting 28 to the power of 3, right? Any questions? Okay, now tell me, right? You have a function y is equal to 8 8x to the power 4, right? So dy over what will come? The variable, the independent variable is what? X. So dy over dx is equal to 8 into 4 into x to the power 4 minus 1, 3. So answer is 32 to the power x. 32 into x to the power 3 is the answer, right? So this is the fourth rule. So if you find out the differentiation of any constants, right, that is 0, right? That's the first rule, right? So if you differentiate any constant value, let's say, if I find out the differentiation, right, you have a function y is equal to 5. If I find out the dy over dx, it is equal to 0. That is the first principle we discussed, right? I will explain all the for what we are discussed up to now. I will explain again, right? So, so normally you need to find out the differentiation by using the first order principle, right? F of x plus limit delta x approaches 0, f of x plus delta x minus f of x over delta x. That is the first order principle. Normally, that is you need to use to calculate the differentiation, right? It's a time consuming task. So the mathematicians find out some set of rules, right? The first rule says if you have a function, it's a k, right? If you have a function y is equal to k, constant value, if we find out the differentiation dy over dx is equal to 0, right? Example, right? If you have a function y is equal to 10, so dy over dx is equal to 0. That is the first one. Second one, if you have a function y is equal to kx plus c, right? C is a constant, k is a constant. So if you find out the dy over dx, there's a linear equation. It is equal to k, right? Because if you differentiate the constant if you differentiate constant c, that is 0, right? Then k into x. So actually what will happen here, k into dx over dx, right? So here x to the power 1, right? Then what will happen, k into, so if this is in the form of x to the power n, right? This is in the form of x to the power n. Then what will happen? We can write 1 into x to the power 1 minus 1, x to the power 0. If any base, if any base, if the index is 0, then we can say this is 1, right? So k into 1 into 1. So that is k. So that's why we are getting this one, right? So this is second form. If you have a linear equation, y mx plus c in the form of mx plus c. M is a constant, c is a constant. Then we are getting k is the dy over dx, right? So the third form, if we have a function y is equal to, right, x to the power n. So that is the third form, right? Yeah, power. If you have a function f of x to the power n, so then we can find out dy over dx is equal to n into x to the power n minus 1. So this is dy over dx in the third form, right? Let's say y is equal to x cube. Then we can find out dy over dx is equal to 3 into x to the power 2, right? 3 into x to the power 2. Just you can write the front 3, then you can minimize 1, right? This is third form. Next form, the fourth form, you have a function y is equal to k into x to the power n, right? So if you have this one, k is a constant, then dy over dx is equal to k into n into x to the power n minus 1, right? This is the fourth form we discussed, right? So if you have a question, y is equal to 5x to the power 7. So if I ask you to find out the dy over dx, so the answer is 5 into 7 into x to the power 6, right? The answer is 35x to the power 6, right? This is the fourth type. So what we have discussed up to now, right? Now we will look at the fifth type, right? So the fifth type means the previous case. We already discussed in the limits as well, right? You have a function y is equal to f of x plus g of x, right? If you have a function this way, just look at here. If you have a function this way, f of x plus d of x, so dy over dx means you can separately differentiate f of x plus you can separately differentiate g of x, right? So separately you need to differentiate the function f of x. Also, you can separately differentiate the function g of x. Similarly, if we have a minus y is equal to f of x minus g of x, here also you can separately differentiate, right? This is the next rule. We can say as a fifth rule, right? If you have a function, right? Just imagine this is the function, right? F of x is one function, g of x is another function. So if I ask you to differentiate this function y, so dy over dx is equal to, first you need to differentiate the function f of x based on x. Similarly, you need to find out the differentiation of g of x based on x, right? Separately you can do. That is the fifth rule. Let's say I give an example, right? Y is equal to x squared, sorry, y is equal to x to the power 7, right? X to the power 7 plus 3x squared, right? Just look at here. So x to the power 7 is a one function. Maybe you are consider this one as a f of x. Maybe you are consider this one as a g of x. So tell me the answer. Dy over dx is equal to what? So you need to separately find out the differentiation for this one. So for find out the differentiation for this one, we know, right? If you have a function y is equal to x to the power n, then we can write n into x to the power n minus 1. So what is the answer here? 7 x to the power 6, right? 7 x to the power x 6, 7 x to the power 7 minus 1, 6, right? Now we need to separately differentiate this one. So now what will happen? This is in the form of k into x to the power n, right? Then I need to write k, then I need to separately 2 into x to the power 2 minus 1, 1, right? Now the answer dy over dx is equal to 7x to the, sorry, dy over dx is equal to 7x to the power 6 plus 3 into 2, 6x, right? This is the differentiation of y, dy over dx is this one, right? So if you have a more than one functions, okay, then you can find out the dy over dx by separately find out the differentiation. Now tell me what is the answer. This one, y is equal to, there is a function y is equal to 2x to the power 4 plus 3x to the power 2 plus 5x. Okay, here you can take whatever, right? Maybe you can take this is a separate function, this is separate function, this is separate function, right? if y is equal to f of x plus g of x, it means maybe it is pi of x also possible, right? Even if you have more number of functions, right? What you need to do, you need to separately differentiate. Dy over dx is equal to d f of x over d of x plus d of g of x over d of x plus d h of x over d of x. How many functions? Maybe you can separately find out their differentiation, right? That is a theory. This rule says, right? Rule 5 says that one. Okay, now what is the answer for this one? Tell me, dy over dx is equal to what? Hmm? Dy over dx is equal to what? First, you need to think this is a separate function, right? So we know how to differentiate this function, right? We already discussed. This is in the form of k into 2, k into x to the power n. So we can write 2 into 4 into x to the power 3. Maybe you don't need to write this way, right? If you are an expert, directly you can write the answer. So it will multiple by this 2. So 4 into 2, 8, 8x to the power 3, right? You don't need to write step by step. If you know the answer, you can directly write 8x to the power 3. Then for this one, I can write the answer 3 into 2, 6, 6x plus 5, right? So maybe if you need, you can write line by line. So 3 into 2 into x to the power 2 minus 1, 1, right? 2x. Okay. Okay, the next one. You may make there's a problem with my writing speed. Okay. Okay, then what will happen? 5x. If I write, if I differentiate 5x, right, I can write 5 into dx over dx. So it is equal to 1, right? So 5x, it means this is the answer for this question, right? Okay, that is the fifth form, right? So the next form, right, you have a function y is equal to f of x whole thing to the power of n, right? Previously, we discussed y is equal to x to the power n. So what is the answer for this one? Dy over dx is equal to, tell me the answer for this one, dy over dx. If you have a function this way, tell me the answer dy over dx is equal to n into x to the power n minus 1, right? This is one thing. And also we discussed some another function, y is equal to k into x to the power n. Then we can differentiate dy over dx is equal to what? K into n into x to the power n minus 1. This is these two types we already discussed, right? So these two types we already discussed. Now another new term, right? Just look at here. You have another new function, new type of differentiation, right? This way. Why? You have a function y is equal to f of x to the power of n, right? To the power of n. If you have this type of function, right? If you have this type of function, right, then we can find out dy over dx is equal to, first thing you need to write as a n, right? Now you need to write the function f of x, right? The similar way, right? Here, y is equal to x to the power n, right? Then I can write the n here. So here also I'm writing the n here, right? Now what will happen? In this case, I am put x. Here, I write the entire function, right? So now what will happen here? N into f of x. Here, x to the power n minus 1. Here, f of x to the power n minus 1. Then I need to get the differentiation of f of dash x, right? Do you get my point, what I'm telling here? So if you have this type of function, first you can write the n here. Then you need to write the entire function here. then you need to write n minus 1, then you need to get the multiplication of, then you can differentiate this function. Internally, you can differentiate this function. So if you have a function f of x, if I differentiate, it considers a f of dash x, right? So this is the form of that one, right? You can understand if I explain with an example. Here also we are doing the same thing, right? Just look at here. If you have a function y is equal to x to the power n, just think about x is a function now, right? Now just think about x is f of x. Now what will happen? We are writing n here, then we are writing the function x, n to the power minus 1. Now we find out the differentiation of x, dx over dx. So that is equal to 1. That's why we are omitting this one, right? Now just look at here, this example, right? You have a function y is equal to yeah, x squared plus 3x plus 5 whole thing to the power of 7. Okay. Now, can you apply this differentiation rule and give me the answer for this? What is dy over dx? Tell me the answer. Just you can apply this principle, this rule, right? You can apply this rule. So you have a function is this way. This is your function. Y is equal to f of x whole thing to the power of n. Then we need to find out dy over dx. So you can write n here, f of x n minus 1, then f of dash x. You can internally differentiate the function, right? Okay. Now tell me what is the answer for this. I'm waiting. Tell me the answer. What is the answer? So just imagine here, right? F of x is equal to, just imagine f of x is equal to x squared plus 3x plus 5. Just think this way, right? This is your f of x. Now you can find out this is in the form of f of x to the power of 7, right? How then I can write, how we can write the answer? Tell me. So first you can write this one, 7 into x squared plus 3x plus 5. You write the entire function, then n minus 1, 7 minus 1, 6. Then you need to differentiate f of dash x. Here you need to write f of dash x, right? So how you can write f of dash x? So how you can write f of dash x? Tell me. So if you have this function, you know what is f of dash x. F of dash x means you need to differentiate 2x plus 3 to x squared. If you differentiate 2x, you can write the power 2 x, x2 minus 1, x 2x, right, plus 3x, right? So the answer is dy over dx is equal to 7 into x squared plus 3x plus 5 whole thing to the power of 6 into, you need to write 2x plus 3. So this is the answer. So if you have a function, not function, right? If you have a function f of x to the power of something, then you can write the answer this way, right? Okay, can you try this one? Okay, you have a function y is equal to 7x squared plus 3. Okay, 7x to the power 4 plus 3 whole thing to the power of 8. What is the answer? Dy over dx. Tell me the answer quickly. You don't need to spend so much of time, right? Just imagine the internal thing. All internal elements has a one function, right? Now we know if we have y is equal to f of x whole thing to the power of 8, then we can write 8 into 7x to the power 4 plus 3 whole thing to the power of 8 minus 1, 7. Then you need to differentiate inside, right? So if you differentiate these things internally, so now this is in the form of k into x to the power n. Then we can write 7 into 4, 28, x to the power 3. That's all, right? If I differentiate 3, that is a constant, right? So if I differentiate the constant, we know that is 0, right? So I don't need to put that one. So it will happen 7 into 4, 28, x to the power 3, right? This is the answer. Any doubts, you can let me know. Any doubts? Any doubts? Okay, I think only another two to three types, right? That's all the types, right? So now we are discuss this one, right? Sixth type, right? Now we will look at the seventh one. Okay. So up to now we are discuss sixth rule, right? If you differentiate a constant, what will happen? That is zero, right? If you have a function in the form of y is equal to kx plus c, the answer is k, right? Then we are discuss f of x plus g of x or f of x plus or minus g of x in the form. Then you can separately differentiate. Third one. Then fourth one we discuss x to the power n into x to the power n minus 1. Fifth one, k into x to the power n minus k to the k into x to the power n. Then dy over dx is equal to k into n into x minus x to the power n minus 1. The sixth one we discuss, you have a function y is equal to f of x whole thing to the power of n. Then dy over dx is equal to n into f of x to the power of n minus 1 into f of dash x. These are the six types we are discussed up to now, right? Only another three or four types, right? I will explain. The next type is product rule. Product rule in the sense, right? If you have a function, you have a function, right? Y is equal to f of x into g of x, right? If you have a function in this form, the differentiation dy over dx is equal to, first you need to write this function, right? F of x. First you need to write this function. First you need to write the first function. Then you can differentiate the second function. So the differentiation we can write g of x plus, then you can write the second function, then you can differentiate the first function, right? This is the next rule, right? You have two functions, they are multiple, f of x into g of x. So first you need to write the first function without any change. You write the first function multiple by differentiation of second function. Right here I can write f of x as the same, then I can find out the differentiate, right? Then plus, in the middle I am putting a plus, then I can write the g of x without any change, then I can get the multiplication of f of x, right? Maybe this is one way. Another way, just think about u is a function, v is another function, right? Y and u and v are functions with x. So it means, right, y is equal to maybe x squared plus 3 or something, right? U is equal to maybe x cube or something. All the equations are y, y, u, v, all are in the functions with x. Just imagine, right? Now you have a function that I will write the another different form, right? Y is equal to u into v. U is a function, v is a function, right? So I will explain the easiest way, right? So to find out the dy over dx, first you need to write u. First you need to write u. Then you need to find out dv over dx plus, first you need to write the v, then du over dx. So this is the next form we are discussed, product rule, right? So first you need to write the first function, then you need to differentiate. Plus you need to write the second function, then you need to write the differentiation of first function, right? So just you can write the first function without any change. Then you can find out the differentiation. Then you can write the second function without any change. Then you can find out the differentiation of first function, right? You can understand if I explain with an example, right? Just look at here. I will explain with an example. Okay, just think about y is equal to, right, x to the power 5 into x to the power, sorry, this is not correct, right? So maybe if I write x to the power 5 into x to the power 7, what did you do? Tell me. If I give you this question, how you can answer? If we discuss the indexes, right? So if you have the same base, if they are multiple, then we can write x to the power 5 plus 7. So x to the power 12. So y is equal to x to the power 12, right? So then what is the answer? Dy over dx is equal to 12 into x to the power 11, right? There is nothing here. There is nothing here in the form of two functions multiplication, right? Just imagine this way, right? Y is equal to x squared plus 3x into, right, 3x to the power 4 minus 5x, or just plus 5x, right? Okay, now if you notice here, right, this is a function. Just imagine this is a function f of x, right? This is another function g of x, or maybe you can say this is a function u, this is a function v, right? Now how we can find out the answer? Dy over dx, differentiation dy over dx is equal to, first you need to write u. So just you can write x squared plus 3x. Then you need to get the differentiation of v. So what is the differentiation of this 3x plus 4 plus 5x? So the differentiation is, so what is the differentiation of this one? Tell me. Just apply the rules what we have discussed earlier. So here what will happen? 3 into 4, 12x to the power 3 plus 5, right? 5x if I differentiate 5 plus, now I can write u differentiate v. Then what I need to do? Tell me, what is the next step? I write u differentiate v. Then I need to write v and differentiate u. So v is equal to 3x to the power 4 plus 5x. Then I can write v without any change. Then I need to differentiate u. So if I differentiate u, what is the answer? So u is what? X squared plus 3x. So if I differentiate x squared plus 3x, 2x plus 3. So this is the differentiation of this function, right? Any doubts? Any doubts? Yeah, the thing here, you need to understand the rules, right? Then only you can answer the questions. So if you have the form of u into v, first you need to write u, then you can differentiate v. Then you can add plus, addition, plus, then you can write v, then you can differentiate u, right? That is we can call uv form, right? Two functions in the form of multiplication. You need to write u differentiate v plus you need to write v differentiate u, right? Okay, now tell me what is the answer for this one. If you understand, tell me the answer for this one, right? You have a function, right? Y is equal to x cube into 3x to the power 4 plus 5x. So what is dy over dx? So just think about, this is as a u, this is as a v. This is u, this is v. Now what will happen? X cube. You need to write x cube. Then you need to differentiate this one. 12x to the power 3 plus 5 plus, then I can write v. V is equal to 3x to the power 4 plus 5x. Then if I differentiate x cube, 3x to the power 2, right? So the answer is 12x to the power 6 plus 5x to the power 3 plus 3 into 3, 9, x to the power 6 plus 15x to the power 3, right? Then the answer is 12 plus 9, then 21x to the power 6 plus 20x to the power 3, right? This is the answer I am getting with the help of what? UV form, right? Maybe without UV form also you can find out the answer. How? Tell me. So y is equal to x to the power 3, 3x to the power 4 plus 5x. How you can find out the answer without UV form? Tell me. If you can't find out the answer with UV form, without UV form also you can find out the answer. Anyone tell me how you can do that one? Without UV form? Without UV form, how you can find out the answer? So just look at here. Only one variable is there, right? Just you can remove the bracket. So you can multiple each element inside the bracket by x cube. So now what will happen? 3x to the power 3x to the power 7, right? If you have the same base, you can get the addition of the index, right? So 3 into x to the power 3 into x to the power 4, 3x to the power 7 plus 5 into x to the power 4. 5 into x to the power 4, right? Now this is a function. Just think about, this is a separate function, this is a separate function. Now in the form of f of x plus g of x. So now we can write dy over dx is equal to, so separately you can differentiate this one. So what will happen? So 3 into 7 into x to the power 6 plus 5 into 4 into x to the power 3. So what is the answer? 3 into 7, 21 x to the power 6 plus 5 into 4, 20x to the power 3. We are getting the same answer for both. Do you notice that one? If you don't remember, just check whether is there any other rules we can apply for these. Right? Any questions? Any questions? Hello? Just talk, right? Otherwise, I can understand whether you are getting or not. Just you can remember the rules. That's enough, right? Don't worry, Asaf. Summary, I will explain all the rules within few minutes, right? So just you can understand the questions, right? How you find out the answers, right? Okay, that rule we can say product rule, right? Product of two functions, right? So we discussed the product rule. The next rule is quotient rule, right? So this means that is a f of x over g of x, right? So previously two functions are multiple by each others. Now one function is divided by another function, right? The numerator and denominators, right? If you have this form, right, you have a function, right? Just imagine you have function this way, right? Y is equal to, okay, you have function this way, right? You have function y is equal to f of x over g of x, right? Only few slides, don't worry. If you have function y f of x over g of x, so to this one, to differentiate dy over dx, what you need to do, first you can write the bottom function g of x, right? You need to write the function g of x. Then you can find out f of dash x minus, so we have f of x over g of x, f of x into g of dash x, right? Over g of x to the power 2, right? This is the rule, right? If you have a function u over v form, right? Just look at here, I'm writing in the way. I have a function y is equal to u over v. To find out the y dy over dx, right? First you need to write the bottom function v, then you can differentiate u du over dx minus, you can write u, then you can find out dv over dx, right? Over the bottom function to the power of 2, right? So first you need to write the bottom function, then you can find out the differentiation of the top function minus subtract. You need to write the first function, differentiate the second function divided by the bottom function to the power of 2, right? This is the eighth function, eighth rule. Okay, I will tell an example. I will show you an example, right? Then you can easily understand. It's not a big it is not a simple subject, right? You need to spend a time, right? Then only you can understand, right? There are so many things to remember here, right? The limits is there. In differentiation, there are so many things. Also, integrations also have these type of things, right? Okay, now I am giving you a function, right? Y is equal to x cube plus 3 x cube plus 4x over 5x squared minus 7, right? Just imagine this is u, this is v, right? We know first we need to write the, so okay, just think about this is a this you consider or this one as a uh, u, this one as a v, right? This is top function as a u, bottom function as a v, right? So how we can find out the answer for this? Try that one. So dy over dx. First, what you need to do? You need to write the bottom function without any change, right? So 5x squared minus 7. Then you need to differentiate the top function. So if you differentiate x cube plus 4x, what is the answer? 3x to the power 2 plus 4, right? 3x to the power 2 plus 4 is the differentiation of top function, right? Minus, then we need to write the top function without any change. 3x, x to the power 3 plus 4x. Then I need to differentiate the bottom function. So if I differentiate bottom function, so 5 into 2, 10x, 10x. That's all, right? 10x here, there's a constant. If I differentiate constant, that is a 0. Over, then the bottom function to the power of 2, right? To the power of 2. So this is the answer, right? Okay. Now tell me y is equal to, okay, 7x squared plus 5x plus 3 over 4, sorry, 4x squared plus 3. So what is the answer? Dy over dx. You don't need to spend much time, right? Just think about this is u, this is v. So first you need to write the bottom function without any change. 4x squared plus 3. Then I need to differentiate the top function. So I need to separately differentiate. 7 into 2, 14x plus 5. Then the constant, it's 0. Minus, then I need to write 7x squared plus 5x plus 3. Then I need to differentiate the bottom function. So bottom function 8x over 4x squared plus 3, whole thing to the power of 2, right? This is the answer, right? Any doubts, let me know. I'm asking you again and again. So that is the eighth principle, right? Okay. Okay, now tell me what is the answer for this one. So now y is equal to 1 over f of x. How you can find out the answer for this? Hmm? What is the answer for this? This is also in the form of u over v, right? We know one y is 1 means, let's say 1 is a constant function, right? Here another function is there, right? How we can find out the answer for this type of questions? Okay, just look at here. I'm giving you a function y is equal to 1 over f of x. Then how we can find out? So what you need to do, dy over, dy over dx is equal to, first you need to write the bottom function, right? What is the bottom function? F of x. Then you need to differentiate the top function. So 1 is a function, right? So if it is a constant function, if I differentiate, the value becomes 0, right? Minus, then I can write a top function. Then I need to differentiate the, then 1 into differentiate the bottom function over bottom function to the power of 2, right? So now what will happen? 0 into f of x 0. So minus f of dash x over f of x to the power of 2, right? Maybe we can find out this one, minus f of dash x over, right, f of x to the power 2. Right now, can you find out the answer for this one? Y is equal to 1 over x square plus 1. Try this one. Try this one. Tell me the answer. Y is equal to 1 over x square plus 1. Tell me the answer. So this is also a u uh, yeah, this is also the u over v form, right? This is in the form of u over v, right? So just imagine this is function u, this is function v. Right now, tell me dy over dx is equal to, first I can write the bottom function x squared plus 1. Then I can differentiate 1. 1 if I differentiate, that is a 0, constant function, minus, right? Then I can write the top function. Then I need to get the multiplication of bottom function, right? So the differentiation of bottom function 2x, if I differentiate 1, that is a 0 over x squared plus 1 whole thing to the power of 2. Right now, what will happen? This is 0, right? This is altogether 0. So minus 2x over x squared plus 1 whole thing to the power of 2, right? This is the answer. Minus 2x over x squared plus 1 whole thing to the power of 2, right? So up to now, we have discussed 8 different rules, right? Okay, that's all, right? Yeah. Altogether, there are 10 types of, 11 types of rules, right? Okay, now we are in the ninth rule, right? Yeah, this one, chain of rules, chain rule, right? So chain rule means, right, we already discussed composition of function. Do you remember composition of function, right? You have a function y is equal to, you have a function y is equal to in f of x, right? You have a function y in f of x, but the function f of x in equal to in another function g of x, right? That is we can call chain rule. Let's say chain rule in the sense, just look at here. You have a function y, that is the variable here is a u is the variable, right? So if it is in f of u, right, the function y in variable u. Similarly, you have a function u that is in different variable x, right? Just I will explain. Just look at here. You have a function y is equal to u squared plus 5u, sorry, 5u squared plus 5u plus 3, right? But you have another equation, u is equal to 7x cube plus 3, or plus 7x cube plus 4x, right? You have a one function y is equal to u squared plus 5u plus 3. But you have another equation in u is equal to 7x cube plus 4, right? Now we need to find out, in this situation, we need to find out dy over dx. That is the next type of rule, right? If we have these type of two function, right, we need to find out dy over dx. That is our solution. That is the question they are asking. We need to find out dy over dx, right? Now, can you tell me, if you look at this function and tell me, this is a function, the independent variable is u. The function, the independent variable is u. The y is depending on u, right? So now we can find out what dy over du, right? If you do a small changes in u, if you do a small changes in delta u in your variable u, how the variable y will change. That is the differentiation, right? From the first order principle. Right now, tell me, if I differentiate this function y by using u, what is the answer here? Tell me the answer for this function. If I differentiate u squared, what is the answer? Hello, tell me the answer. I can't repeat the things, right? So if you miss today, you face the final exams only. So just think about that one. If you have any doubts, let me know. Otherwise, I can't understand, right? So if I differentiate this equation, y is equal to u squared plus 5u plus 3 by using, if I differentiate with u, so 2u plus 5, right? This is dy over du. Now, similarly, if I differentiate this equation u, this function u with x, du over dx, right? This is a function, the variable x. So now what is the answer? 7 into 3, 21 x to the power 2 plus 4, right? Now I know two things, right? I know two things. What? Dy over du I know, right? Also du over dx I know. So my question is dy over dx, right? So I can write dy over dx is equal to dy over du multiple by du over dx, right? In both side of the equation, I can multiple by du. Is it possible, right? If you do a change both side of the equation, there is nothing will happen. That's a explicit explicit true, right? So dy over dx is equal to dy over du multiple by du over dx. But I know what is dy over du. So dy over du is what? 2u plus 5. Then if I multiple by du over dx, that is what? 21x squared plus 4, right? But the important thing here, if you need to find out the differentiation dy over dx, we cannot put with u, right? Now what you need to do, dy over dx is equal to, for u, you can replace with the function what we are assigned. So for you can put as this one. For you can put this one, right? So now what will happen? Dy over dx is equal to 2 into, for you can replace by 7x cube plus 4x, right? 7x cube plus 4x plus 5. Then I can multiple by, so 2 into uh, I can replace with 7x cube plus 4 plus 5. Then I can multiple by 21x squared plus 4, right? So this is the differentiation dy over dx if I apply the chain rule, right? Okay, can you find out the answer for this one? Okay, okay, just look at here. You have two function, y is a function with u, the variable u, but they are telling u is a function with the variable x squared plus 1. Can you find out the dy over dx? Try yourself, tell me the answer. Try yourself and tell me the answer. How to differentiate? Anyone tell me the answer? Try yourself and tell me. Okay. Yeah, just look at here. I will explain the answer, right? First, you can look at, right? Now we have two functions, right? Just look at here. We have a function, right? Y is equal to u squared minus 1 over u squared plus 1, right? Now we can find out only dy over du. So this is in the form of u over v. So first you can write the bottom function, u squared plus 1. Then you can differentiate the top function. So u squared minus 1, if I differentiate 2u minus, I need to write the top function u squared minus 1 into, I need to differentiate the bottom function. So that is also 2u. right, over u squared plus 1 whole thing to the power of 2. Right. Similarly, if I differentiate this function, so u is equal to, just imagine this way, right? X squared plus 1 whole thing to the power of, if it is a 1 over 3, right? So if it is a 1 over 3, right? So third root, right? So it means 1 over 3. So you have a function. Just imagine this is equal to, y is equal to f of x whole thing to the power of n. Just you can find out this one, right? Then only you can answer the question. So this is equal to this way. So then we can find out du, we can find out du over dx is equal to, so first you can write the 1 n, right? 1 over 3 into x squared plus 1, then 1 over 3 minus 1. Then I need to differentiate internal function. So if I differentiate the internal function, x squared, if I differentiate 2x, if I differentiate constant, that is 0. So now we know du over dx is equal to 1 over 3 into, here I can write x squared plus 1 whole thing to the power of minus 2 over 3 into 2x, right? Now, if I apply chain rule, dy over dx is equal to dy over du, dy over du multiple by du over dx, right? So for dy over du, just you can replace this formula, right? Similarly, for du over dx, you can replace here. But in the dy over dx, we only have x and y. So here, all the you need to replace by this one, right? This is the way you can find out the answer if I apply the chain of rule, right? Okay, the next differentiation for log function, right? So the next differentiation for log function, right? Now you know, right, what is log. So 2 to the power 3 is equal to what? 8. 2 to the power 3 is equal to 8, right? If I take log, so if I convert into log, what will happen? Log 2 to the power 8 is equal to 3, right? So 2 is the base, right? Here, we will only consider the log of e base, right? So we know log log base 10 we can say as a lg, right? Similarly, log e base we can say ln. This is lg logarithm, this is ln logarithms, right? If you have a base with e, we can say ln, right? Okay, now just think about, you have a function y is equal to log e to the power x. So this function we can write ln x. So if you have a function ln x, right, we can find out the differentiation of this function. Let's say y is a function of ln x. So now we need to find out the differentiation of dy over dx. For this one, we can write 1 over x. If I differentiate ln x, this is another rule. If I differentiate a function ln x, this is equal to dy over dx is equal to 1 over x, right? Okay, now what will happen if you have a function ln x, first this is a function, right? Then you can write the function 1 over x, then you can multiple by dx over dx, right? That is 1, right? So now just look at here, you have a function y is equal to ln 2x. So ln 2x means nothing, right? Y is equal to log e to the power, right? Log e to the power 2x. Log e to the power 2x is we can call function with log, function with base e, right? This is equal to this one. So if you have a function with base e, we can write special letter by ln, right? So if you have a function ln 2x, this is a function. So if I ask you to differentiate dy over dx, now it is equal to, we can write 1 over 2x, then we need to differentiate 2x, right? So if I differentiate 2x, so if I differentiate, let's say you have a function g is equal to 2x. So if I find out dg over dx, that is equal to 2, right? So the answer is 2. 2 over 2x is equal to 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 2 over 2x, right? This is the maybe, yeah, this is the one rule, right? So just look at here. If you have a function, right, ln x, so if you differentiate this function, that is 1 over x, right? That is one type. Now you have another function, y is equal to k is a constant into ln x. Right now, what will happen? Dy over dx is equal to, just you can write the constant 1 over x. That's all. Constant over x. Right? Maybe you can apply for this uh, for chain rule. Chain rule you can apply for here as well, right? Just look at here. Y is equal to log e base u, right? Then they are giving u is equal to f of x, right? Now we can find out dy over dx. So for this one, we can write ln u, right? So ln u, this is ln u. So dy over dx means dy over du multiple by du over dx, du over dx, right? This is a theorem. So dy over du means dy over du. So if I differentiate this one with the help of u, so 1 over u multiple by, if I differentiate u, f of dash x, right? Now for u, I can write 1 upon f of x into f of dash x, right? So the last principle, exponential function rule, right? The last principle, if we have a function, exponential function, right? Exponential function. First, you need to understand what is exponential function, right? So the exponential function in the sense, right? The exponential function in the sense, right? Previously, we have a function y is equal to x squared or something, right? So exponential means, let's say if you have a polynomial function, this is a polynomial function, right? So the power of each variable we can call exponent, right? This 3 is an exponent of this x. This 2 is an exponent of this x, right? Here, what is the exponent? 0 is there, right? 5 means 5 into 1. So 1, we can put x to the power 0. Here, the exponent is 0, right? So exponential function means a function, right? Exponents means the index of a letter, right? So exponential function means this form, right? So the variable have in the index, right? Your variable assigned as an index, right? So here the base is 2, but the variable is in the index, right? This function we can call x, y is equal to 2 to the power x, we can call exponential function. Maybe y is equal to e to the power x. This is exponential function because e has a stable value 2.7 or something. You have a specific value. So if you have a function y is equal to e to the power x, if you differentiate function y based on x, dy over dx, e to the power x, if you differentiate e to the power x, there is no change, right? Then what will happen? You need to differentiate x dx over dx, right? So that is a formula, right? So it means if you have a function y is equal to e to the power f of x, that this form says if you have a function y is equal to e to the power f of x, if you differentiate this function dy over dx is equal to e to the power f of x into f of dash x, right? So you have a function. If you differentiate e to the power f of x, e to the power f of x into f of base x, right? So that is the form, right? E to the power f of x. First, I can write e to the power f of x without any change. Then I need to get the differentiation f of dash x, right? Okay. I think that's all, right? So just look at here some example, right? Okay. Okay. Just look at here. There is a function, right? Y is equal to, okay, 2 to the power x. Okay. Can you differentiate this one? So dy over dx is equal to, so this is in the form of e to the power x, right? So here we can write 2 to the power x. Then we need to differentiate x. If I differentiate based on x, dx over dx is equal to 1. Right? So the answer is 2 to the power x. Now tell me y is equal to 2 to the power 3x. What is the answer? dy over dx is equal to 2 to the power 3x into, I need to differentiate 3x. If I differentiate 3x, what is the answer? If I differentiate 3x, 3 is the answer, right? So 3 into 2 to the power 3x is the answer, right? Now tell me y is equal to e to the power x squared plus 3x plus 5. What is the answer? dy over dx is equal to, so if I differentiate e to the power x, the same e to the power x come first, right? E to the power x squared plus 3x plus 5. Then I need to get the multiplication of, then I need to get the differentiation of this one. So what is the differentiation of this one? 2x plus 3, right? So this is the answer, dy over dx, right? Okay. Now what is the answer for this one? dy over dx is equal to e to the power 3x plus 2 into, then I need to differentiate this one. 3x plus 2 differentiate 3. 3x if I differentiate 3. If I differentiate constant, that is 0. So the answer is dy over dx is equal to 3 into e to the power 3x plus 2. Right? These are all the different types of differentiation functions. Right? That's all. Altogether, we discuss yeah, how many types? 11 types of rules in differentiation, right? If you don't remember these 11 types, you need to apply the first order principle and do the things. That is a very time consuming task. Because of that, we remember these 11 rules and you can find out the answer, right? Okay, don't worry. I will give you some questions for practice, right? You can familiar with the differentiation, right? So up to now, just you can remember what are the principle we are discuss, right? Okay. Uh, okay, just I will give you a summary. Just look at here. If you have a function y is equal to k, so what is the dy over dx? What is dy over dx? dy over dx is equal to 0, right? Now, okay, just I am giving you all 11 types, right? Then just a revision, right? What are the things what we are discussed up to now? Now, this is first type. So second type, yeah, this is first type. Now we will look at the second type, right? Y is equal to kx plus c. K and c are constants, right? This is a linear equation. So dy over dx is equal to what? dy over dx is equal to k, right? The third form, y is equal to x to the power n. Then dy over dx is equal to what? N into x to the power n minus 1, right? The fourth one, y is equal to f of x, sorry, y is equal to f of x to the power n. Then what will happen? dy over dx is equal to n into f of x to the power n minus 1. Sorry, I write this way, right? So f of x to the power n, f of x to the power n. So dy over dx is equal to n into f of x to the power of n minus 1 into f of dash x. This is fourth type, right? Then the fifth type, y is equal to k into x to the power n. So dy over dx is equal to what? K into n into x to the power n minus 1, right? Then we look at y is equal to f of x plus or minus g of x. So dy over dx is equal to f of dash x plus or minus g of dash x. So it is separately you can differentiate, right? So then we are look at the seventh form. Seventh form, y is equal to uv form. Two functions multiplication in the uv form. So then dy over dx is equal to, you need to write u, then you can differentiate the v plus you can differentiate, you can write v, you can differentiate u. So the eighth one, y is equal to u over v. So then dy over dx is equal to, first you can write the bottom function v, then you can differentiate the top function, minus you can write the top function, you can differentiate this bottom function, divided by v to the power 2, right? This is eighth. So ninth rule, we discuss chain of rule, right? Chain of rule. If you have a function f is, y is equal to u, then u is equal to f of x. Then dy over du over dx, right? So dy over dx is equal to dy over du multiple by du over dx. This form, right? Then the 10th one we discuss, right? If you have a function y is equal to ln f of x, right? If you have this type of function, if you differentiate, dy over dx is equal to 1 upon f of x. Sorry, yeah, we didn't discuss this one, right? I don't remember this we discussed or not. There are so, this is not the thing, right? More than that we have, right? I explain only few things for you, right? Yeah, chain of rule. Yeah, first I will revise the things. Yeah, constant function, linear function, power function, constant with power, plus or minus some function. Then the yeah, f of x. Then product function, quotient rules. Then we discuss chain rules. Then yeah, log functions, right? Yeah, I will explain ln x, right? Yeah, then fine. I will explain ln x and e to the power x, right? Yeah. Yeah, we will discuss the ln x, right? So you don't need to worry. So the next function, if you have a function y is equal to ln f of x, so dy over dx is equal to what? Dy over dx is equal to 1 upon f of x into f of dash x, right? Do you remember this one? So this principle, right? Just imagine you have a function ln x. Then you can write dy over dx is equal to 1 upon x into dx over dx, right? So that is the next rule, right? The last one, exponential rule, right? We discussed the exponential rule. The 10th one, if you have a function ln f of x, ln f of x, then 1 upon f of x into f of dash x, right? The last one, if you have a function y is equal to e to the power f of x, right? If I find out the differentiation dy over dx is equal to e to the power f of x into f of dash x, right? These are the 11 principle we apply for differentiation, right? If you need, you can take a screenshot of this one, right? This is a summary of the things what we are discussed up to now in the differentiation, right? Any questions? Okay. Yeah. Up to now, what we are discussed, that is we can call first order differentiation, right? So here we are only discussed for algebra, right? Similarly, we have applied these differentiation rules for trigonometry as well, right? I didn't include for your content, right? You're already confusing, right? I know it's very difficult subject, right? So I know you already in a big trouble, right, to understand those things. So I omit the trigonometry part, right? So similarly, we know sine, cos, tan, right? So if I differentiate sine x by using x cos x, if I differentiate cos x by using x, that is minus sine x. Likewise, you have there are a bunch of rules, right? I didn't include those things, so you don't need to panic, right? Just you can practice with these 11 rules, right? Just you can practice with 11 types of functions. That's enough. Okay. So for your exams, I include between these two, right? So now we are discuss dy. Let's say you have a function y is equal to, maybe you have a function y is equal to f of x, right? Now we will find out dy over dx. This dy over dx we can call uh, first order differentiation, right? We can call this one as a first order differentiation, right? So if you have a function y is equal to f of x, right? I'm getting the differentiation dy over dx. This is called dy over dx, we can call first order differentiation. Similarly, we have second order differentiation, third order differentiation, fourth order differentiation, right? So if second, third, fourth order differentiation means there is nothing, right? Let's say in this example, first I have a function y is equal to f of x, then I can differentiate dy over dx, right? Now, for dy over dx, I am getting something, right? So if I again differentiate this dy over dx, if now I am getting a dy over dx, now again if I differentiate based on x, if I differentiate again with x, this dy over dx, this is called d2y over dx squared, right? This is we can call second order differentiation, right? Second order differentiation, right? Similarly, let's say now if I differentiate this d2y over dx squared again with by using dx, this is we can call d3y over dx cube. This is we can call third order differentiation, right? Likewise, it will goes until n order differentiation, right? So it means, let's say I'm giving you an example, right? So just imagine you have a function y is equal to x to the power 7, right? So what is dy over dx? So dy over dx is what? So just apply the theorem, x to the power n, 7 x to the power 6. So now if I differentiate this 7 x to the power 6 using dx, so it means the answer of dy over dx, I need to differentiate again. Now what will happen? 7 into 6, x to the power 5, right? It means 42 x to the power 5, right? If I differentiate again, d3y over dx cube. So this is we can call d2y over dx square, right? So the this one we can call d2y over dx square. This is 42 x to the power 5, right? Similarly, d3 y over dx cube, it is equal to 42 multiplied by 5 into x to the power n minus 1. It means nothing. Again and again, you can differentiate the equation, right? So x to the power n minus 5 minus 1. So 42 into 5, 210 x to the power 4, right? Similarly, if I find out uh, fourth order differentiation, d4 y over dx to the power 4, 210 multiplied by 4 x to the power 3, right? Likewise, we can find out higher order differentiation as well, right? This is explained here, right? So if you have a function f of x, if I get the first order differentiation f of dash x, so maybe if it is a second order differentiation f of double dash x, f of triple dash x means third order, f of 4 dash x means fourth order differentiation, until it will goes until n order differentiation, right? Here what will happen? We are differentiate the function y, right? Here we are differentiate the dy over dx. Here if you are differentiate the d2y over dx square, right? So this is called nth order differentiation, right? Okay, now there's a small exercise. Okay, okay, now in this question, right, I am asking you, there is a function y is equal to x to the power 4 plus 3 into x to the power 2 minus 2x plus 7, right? This is a function. I'm asking you third order derivatives. Now I need d3y over dx cube, right? Can you find out the answer for this one? So it means you need to differentiate 3 times this equation, right? That's all. Not, that is nothing. That you can differentiate 3 times. So just first differentiate dy over dx, the first order differentiation. So it is, you need to separately differentiate, right? So this is a f of x plus g of x in the form, right? Now if I differentiate separately, now what will happen? 4x cube plus 3 into 2, 6x minus 2, right? Then if I differentiate d2y over dx squared, then 4 into 3, 12x squared plus 6x. If I differentiate 6, then the minus 2, if I differentiate, that becomes 0. Right now, if I again differentiate, d3y over dx cube is equal to 12 into 2, 24x, 24x, then this is 0. So the answer, if I differentiate 3 times, d3y over dx is equal to 24x, right? So similarly, if I do for this question, right? So now what will happen? Y is equal to x into 1 minus 2x whole thing to the power of half, right? So I can write this one, dy over dx. First, this is in the form of UV form, right? So first I can write x, right? Then I need to differentiate this one. So half into 1 minus 2x whole thing to the power of half minus 1 minus half. Then I need to integrate internally, right? Constant 0 minus 2x 2 minus 2, right? So plus, then I can write uh, 1 minus 2x whole thing to the power of half into, if I differentiate x, what is the answer? X dx over dx 1, right? So this is 1. So now we know dy over dx is equal to, so I can cut this one and this one, right? Minus x over 1 minus 2x whole thing to the power of, maybe we can write this one as a whole thing to the power of half, plus, so here what will happen? 1 minus 2x whole thing to the power of half, right? Again, I can differentiate this one and this one. This is in the form of u over v form, right? So you can apply for this one u over v form. For again, you can apply for the this one to find out d2y over dx squared, right? Similarly, here u over v form. First, you can find out this is a u over v form. Then first you can find out dy over dx. First, you can write the bottom element. Then you can differentiate the top du over dx minus. Then you can write the top element, top function. Then differentiate bottom function. Then you can over bottom function to the power of 2. Then you can again and again 3 times you need to apply, right? You know what is speed, right? Tell me what is speed. Speed is what? Speed means how long you travel, the distance divided by the time, right? The change of distance between time, we can say that is a speed, right? What is acceleration? What is acceleration? How your speed change, the change of speed divided by time, right? These things we learn, right? Let's say someone says a person travel 50 meters in 3 seconds, or one person travel 50 meter in 5 seconds, right? So someone travel 50 meters in 5 seconds. So they are asking what is the speed of that person. So speed is equal to 50 meter travel by 5 seconds. So his speed is 10 meter second minus 1. So in one each second he travel 10 meters, right? That is his speed. 50 meter he travels in 5 seconds. That is the meaning, right? So the distance he travel 50 meter divided by the time he travel 5 seconds, 50 over 5 is the 10, that is the his speed, right? Similarly, now they are telling, right, a vehicle has a beginning speed of 50 meter second minus 1, right? Right? This is their beginning speed. In 10 seconds, they reach the speed of 150 meter second minus 1. Now they are asking what is the acceleration of that vehicle. So how you can find out the acceleration? the difference between the speed 150 minus 50 over the time duration it takes 10 seconds, right? 100 divided by 10, then 10 meters second minus 2, right? This is their acceleration. These things we discuss in your O-level physics. So maybe you can learn those things in grade 10 likewise, right? This is a physics. We have a speed and acceleration, these two things, right? Now we will look at how we can apply how we can apply the differentiation to find out the velocity, right? So now we know, right? Just imagine now up to now we discuss a function f of x is equal to x squared plus 5x or something, right? So now if I do a small change in the variable x, how my f of x will change? That is the differentiation, right? Average rate of change, right? Now just think about if I have a function, right? If I have a function with t, with time, if I have a function with time, just imagine I have a function with time, right? Just I will take the same thing, right? I have a function s, that function, the variable, changeable variable, independent variable is time, right? So s of t is equal to 120t minus 16t squared, right? So it means they do something and they find out the relation between the time and his distance he moved, right? This is a function, right? So this is a function with time, right? Let's say if I put t is equal to 1 means the distance the by vehicle travel in 1 second is 120 into 120 minus 16 to the power of 1, 16. So altogether 100, he travel in 1 second 104 meters, right? So if I put t is equal to 2 means in 2 seconds the vehicle travel 120 into 2 minus 16 to the power of 2 to the power 2, 4, right? Then 120 into 2, 240 minus 64. So it means 176 meter they are traveling in 2 seconds, right? This is a function. Function means the relation between the variable, right? There is nothing function. The relations between the variable, right? So if I put different times, we will find out from this function what is the variable, right? Now we know this is a function, right? From this function, if I do the different values for the time, right, it will give me the distance how they are travel, right? Now we know if you have a function, we can apply the differentiation for the function, right? Now tell me, this is a function, the variable, independent variable is t. So it means you do a small changes, small increment of t, how the distance will be changed. That is, we can call differentiation for this function, right? If I do a small change in the time, how the distance will be changed, that is we can call differentiation in this function, right? So that is what, if I find out dst over dx, sorry, here dt, right? Because this is a function of t. So if I find out this ds over dt, that is we can call ds over dt, we can call that is velocity. Did you get my point? So velocity means distance, change in the distance divided by the time. That is velocity, right? Now just look at here. Now I get the ds over dt, right? So that is my velocity, right? Again, if I do a second differentiation with time, that is the acceleration, right? That is we can call, that is acceleration, right? So if I differentiate two times the function ds, d2 t over dt squared, that is my acceleration, right? First you need to understand this, that is important, right? Then only we can move for the applications, right? So now just think about, if I find out the dt over dx, that is the velocity. If I differentiate two times, that is my acceleration, right? So now I will explain with the example, right? Now they are giving a equation. The distance s in meter, an object moves in t seconds is given by this equation, right? Just look at here. This is the equation what I told you right earlier, right? Now they are asking some questions. For these questions, you need to apply the differentiation, right? So what is the first question? What is the velocity after 3 seconds? So we know only the equation with time, right? How the distance varying with time, right? That is the equation is S is S to the power T is equal 120 T minus 16 to the power T square, right? So to find out the velocity, first thing I need to differentiate this equation, this function, right? If I differentiate with the help of T, need to use T to differentiate. So ds over dt is equal to, so 120 is a constant. If I differentiate dt over dt, it is equal to 1, right? Minus 16. If I differentiate t squared, 2 into t to the power 2 minus 1, 1, right? So now what will happen? ds over dt is equal to 120 minus 16 into 2, 32 t, right? This is my velocity function, right? This is my first differentiation, first order differentiation. So this is the function. This is the equation for my velocity. So now what they are asking, what is the velocity after 3 seconds, right? The velocity is not stable, right? So depending on their movements in each second, the velocity will be varying, right? So we cannot say all the second they have same velocity, right? Now they are asking what is the velocity after 3 seconds, right? Now what we can do, ds over dt is the velocity we know, right? In this I need to put t is equal to 0. So now what will happen? 120 minus 32 into, here t is equal to what? 3 seconds, right? So 3. So 32 into 3, then 120, right? The velocity becomes 120 minus 96. Then they travel 24 meters after, sorry, their speed is 24 meters second minus 1. That is their speed, right? So now they are asking the second question about the acceleration in 3 seconds. So how you can find out the acceleration? So here in the ds, we already know ds over dt is equal to 120 minus 32 into t, right? Now what will happen? Again, I need to differentiate d2s over dt squared is equal to, if I differentiate 120, that is a constant value. So 0 minus 32 dt over dt, 1, right? So my d2 over ds d2s over dt. So the acceleration d2s over dt squared is equal to minus 32, right? So it means here the acceleration will not change with the time, right? Now I can put here in that, if I put t is equal to 3, then the acceleration minus 32 meter second minus 2. It means if why it comes minus, they are starting on one direction, then they will accelerate in the opposite directions. That is what we are getting minus value. You don't need to worry about that one. So if you need to tell the acceleration 32 meter second minus 2 in the opposite direction, that is the second question. Right. The third question they are asking, right? The first question, what? The first question 24 meter second minus 1. Second question 32 meter second minus 2. We are getting these two answers, right? With the help of a differentiation, right? So the third question they are asking, in which time the velocity becomes 0. So velocity becomes 0 means ds over dt is equal to 0. Do you get my point? ds over dt is equal to 0. Then only we can say velocity is equal to 0. So just you can equalize ds over dt into 0. Already we know ds over dt 120 minus 32t is equal to 0. Then we can say 120 is equal to 32t. So t is equal to 120 divided by 32. So t is equal to what? So 8, 30, right? 15 over 4. So the time 3.75 seconds, their velocity becomes 0, right? So if you look at here, 3.17, 15 over 7, 15 over 4, right? So these seconds, their velocity becomes 0. This is the way we can find out where the velocity becomes 0, right? The next question, Okay, we will stop these, right? We don't need to think about more, right? It's already your confusion, so I will omit these things, right? Okay, don't worry. So this is the application, right? This is one application, right? This is not only one application, right? Another application is there, right? We know a function f of x, right? F of x means x squared plus 5x plus 3 or something, right? So now just look at here. If I plot this graph, right, maybe it will goes this way, right? Now we know we learn something called tangent. Tangent means that is the line we are drawing in the function in a particular place, right? So yeah, better way. I can draw a line and so that's just look at here. Okay, this is the function, right? This is f of x, right? Now we need to find out the tangent. This line, this straight line we can call is tangent, right? This straight line we can call tangent, right? So for the tangent in Tamil we can say totally, right? Totally. This is in Tamil. I don't know the name in Sinhala, right? So if you have a function, on that function, we can find out the tangent line, right? We already learned the things. To find out the equation of a straight line, you need 2 points, right? If you know 2 points x1, x2, also if you know 2 points, let's say x1, y1, right? X1, y1, similarly x2, y2, then you can find out the equation for straight line. Y2, the equation say y minus y2 equal to y2 minus y1 over x2 minus x1 into x minus x1, right? This is a equation. This is one way. Another way, if you know the m means what? M is the gradient of the function, as well as if you know 1 point x comma x1 comma y1, then you can find out the equation. Y minus y1 is equal to m into x minus x1. These are the two ways we can find out the equation for straight line, right? So to find out this tangent equation, to find out this tangent equation, right? We know normally in the questions, they are giving that point. So what is this point? They are giving the coordinate of this point. Let's say x naught comma y naught is the coordinate of this point, right? Now, if you know if you know the gradient of this function, right? If you know the gradient of this function, then if you know the gradient of this function, then you can draw the tangent line equation, right? So now if you have a function this way, x squared plus 5x plus 3, right? Then if you find out the f of x over dx, right? That is we can call the gradient. That is we can call gradient m, right? So if you have any function, right? If you find out that functions dy over dx, the first differentiation, that consider the gradient of that function in that particular point. That is the gradient of that function, right? So if you put the, let's say, if you have this is a function, right? Can you differentiate this one? Can you differentiate this one? So differentiation is 2x plus 5. 2x is plus 5. This is the differentiation df of x over dx, right? So let's think about, they are giving a point. They are giving a point, right? This point they are telling 2 comma 3 is the point, right? Now to find out the uh, gradient of df of x over dx at 2 comma 3, then just you can replace here. For x, you need to replace 2, right? The first coordinate is the x coordinate. So 2 into 2 plus 5. So now the gradient m is equal to 9, right? So m is equal to 9. We know 1 point, 2 comma 3 is the point. So if you know the gradient as well as one coordinate, by using these two things, you can find out the tangent line equation. So y is equal to y minus y1. Y minus y1 is equal to m into x minus x1. So then we can replace y minus 3 is equal to 9 into x minus 2. So y minus 3 is equal to 9x minus 18. So we can write y is equal to 9x plus minus 15. So this is the equation of that straight line. So this is second application, right? I will stop here, right? Only two applications, no? So it's enough, right? Not only that, there are so many millions of application with the help of uh, differentiation. If you wish, I will explain another thing, right? So we already in the first class, I will explain something, right? I will explain that third one, right? The third one is we can find out the minimum and maximum values with the help of differentiation, right? Just imagine in the first class, I told you the perimeter, right? Just imagine, right? They are giving a rope with a perimeter, right? They are giving a rope, that perimeter, let's say this is X, X is the length, Y is the width of the rope, right? The length of the rope, so it means the total length of the rope means, let's imagine 48 meter, right? They are giving 48-meter length rope for you, right? Now they are asking, right, we need to create a square, sorry, we need to create a rectangle, sorry, we need to create a rectangle with maximum area. With maximum area, we need to create a rectangle, right? So they'll give the length is 48. So if you give this type of quick questions, first we need to create a function, right? We need to create the relation between these things and create a function, right? Now we know area is equal to what? X into Y, right? So the length into width, that is the area, right? So this is area is equal to length into width, X into Y. We know another function, right? So if they are giving the perimeter, sorry, perimeter in the sense the total length of the rope, right? So 2x. So this x means this is also x. This y means this also y. So 2x plus 2y is equal to 48, right? Then we can write x plus y is equal to 24, right? Then we can write x is equal to 24 minus y, right? So this is x is equal to 24 minus y. Now we have an equation a is equal to x into y. Now I am replacing x with this one. So 24 minus y into y. So this is the equation for my area. So now I can remove the bracket. So 24y minus y squared, right? This is the equation for a, right? So the differentiation says, right, if you find out dA over dy, on that point, you get the maximum y, right? That is a theory, right? If you do a differentiation, on that point, you are getting the maximum value for your area with that particular y, right? The thing what it says, right? This is a function, right? So function will always become a this way or this way, right? Now what will happen in this point? This is we can say top or bottom points, right? On that top or bottom points, what will happen? Dy over dA is equal to 0 because why? That is already I told you dy over dx is equal to the gradient, right? So if you have a graph, if the gradient is equal to 0 when if it is parallel to the x-axis, right? So then in the maximum or minimum, dA over dy is equal to 0. This is theorem. This is a theorem. Well, it is explicit truth, right? So now what we need to do, if you have an equation a is equal to 24y minus y squared. So if I differentiate this one, so dA over dy is equal to 24 dy over dy 1 minus 2 into y, right? So this is the differentiation of dy over with area and the length, right? Now we know dA over dy is equal to 0 in the maximum point, right? Now if I equalize 24 minus 2y into 0, then what will happen? 2y is equal to 24, right? Then y is equal to 12 meter, right? So if it is a y is equal to 12 meter, x is equal to, so we know x plus y is equal to 24. So x also 12 meter, right? So if you create the width and length with 12 meters, then only you are getting maximum area for your rectangle. This is one example. Likewise, whatever the applications you can apply the first you need to find out the relation, then you can find out the differentiation. From that differentiation, you can learn the minimum usage of resources as well as maximum usage of resources, right? So I will explain with three examples, right? There are so many. I will omit the remaining things, right? I will omit these two, right? So we are discussed the velocity things. Then we are discussed the tangent line, right? for a function. Third one, maximum and minimum. These are the three things we discuss in the applications of differentiation, right? Now we know, right, if you have a function f of x, right? Now if you have a function f of x, right? If you differentiate this function, right, just imagine you have a function f of x. So just think about it. If you have a function f of x, right? If you differentiate, just look at here, right? Just clearly understand about integration, right? Now we are moving for the topic called integration, right? Now we are moving for the topic called integration. So the symbol of integration is this one, right? This is a symbol of integration, right? If I put this symbol, you can understand this is an integration symbol, right? So with the help of integration, we can find out the areas of different maps or something, right? That is the way they are calculate the area of our country, 65,610 kilometers, right? With the help of integration, there are so many applications to find out the areas. Sorry for that, right? Don't worry. I will give very simple questions on the differentiation, right? It's not a simple topic. I accept that one, right? The better way I will share the slides, just you can practice with the questions, right? So here the similar concept, all the concepts what we are discussing the differentiation here also that is available, right? But I didn't teach you all the things, right? Just I will omit most of the things and just I will give a brief introduction about integration, right? So integration means the vice versa of the differentiation, right? So the first point, right? Integration is the opposite direction, the opposite functionality of the differentiation, right? It is the opposite process of differentiation, right? The opposite process of differentiation. Now you know if you have a function f of x, right? If you differentiate, if you differentiate this function, let's say we know, just imagine f of dash x, right? Now if you integrate this f of dash x, if you integrate, right? If you integrate this f of dash x, you are getting this f of x. That is that is the entire thing, right? Previously, if you have a function, if you differentiate that function, you are getting a something, right? That's also a function or something, right? Just imagine, right? Look at here, f of x is equal to, right, x cube plus 5, right? Now, can you tell me what is the f of x over dx? If you differentiate this one, what is the answer? Tell me the answer. 3x to the power 2, right? So it is in the form of x to the power n into x to the power n minus 1, right? So 3 into x to the power 2 plus if I differentiate 5, it is 0. So I don't need to put this one. So now you have a function f of x, right? If you differentiate this function, you are getting 3x squared plus 3 into x is x to the power 2. You are getting that one, right? Yeah, it's okay. I will send the session video, right? Don't worry. Okay. Just look at here. You have a function f of x is equal to x squared. You have a function x f of x is equal to x cube plus 5. If I differentiate this function, I am getting a result 3x squared plus 2. So depending on this definition, right? If I integrate 3x squared by using x, so this is the integration. If I integrate this function 3x squared by using x, I am getting x cube plus 5, right? This is the internal meaning of this, right? If you have a function, if you differentiate that function, right, you are getting something, some function or some outputs, right? So if you integrate that output, you are getting that differentiated function, right? So if you have a function, right, this is a function. If you differentiate this function, you are getting this one, right? Now, if you integrate this function, you are getting the function which one you differentiate, right? That is we are called vice versa, right? Did you get my point? If you have a function, if you differentiate that function, you are getting a something, right, as an output. So you are integrate that output, you are getting function which you the function which you differentiate, right? So now if you are differentiate, let's say now tell me, right, you have a function f of x is equal to 5x to the power 4 minus 7x, right? Okay, this is the function, right? Now tell me what is the answer if I integrate 20x to the power 3 plus 7. So if I integrate this elements, if I integrate this 20x to the power 3 plus 7, what is the answer you are getting? Tell me. What is the answer you are getting? Just understand the definition of things, right? If you have a function, if you differentiate that function, you get something, right? So the output you are getting, then if you integrate that output, you are getting the function which one you differentiate, right? That is the previous thing I explained. Now I am giving you a function f of x, right? Then I am asking you if I integrate this one, what is the answer? So there's a small logic. So up to now, you don't know how to integrate the things, but you know how to differentiate the things, right? Just apply the principle and tell me the answer. What will come for this one? So how you can find out that you don't know only one thing, right? Only you know how to differentiate. So just differentiate f of dash x is equal to what? If you differentiate this function, what will happen? So 5 into 4 into x to the power 4 minus 1. So 20x cube plus 7 into dx over dx 1. So what will happen if I differentiate, if we have a function, right? If you differentiate this function, we are getting 20x cube plus 7, right? Now I am asking the output of the differentiation as a integration. What is the answer? Tell me the answer. That's why I again and again tell you. Tell me what is the answer. Now already I told the answer also, right? Tell me. You have a function f of x, right? If I differentiate this function, I'm getting this as a result, right? Now, if I integrate this one, what is the answer for this one? Hello, I didn't give any recordings, right? If you don't answer, definitely I didn't give any recording. I think no one is look at the lectures, right? Just forget the differentiation. Now just can move for the integration. So if you have a function, right, just think about x squared plus 5x or something. That's a function, right? If you differentiate that function, you are getting some output, right? Maybe that is also a function, right? Now, if you integrate that output function, you are getting the function which one you are which one you are differentiate, right? If you have a function, you differentiate that function, you are getting some output. Maybe that is also a function, right? If you integrate the output function, you are getting the function which you differentiate. So what is the answer? What is the answer? Yeah, very good. That's why I'm asking you, right? So the answer is if I integrate this one, 5x to the power 4 plus 7 is the answer for my integration, right? So that's why I told you the reverse process of differentiation we can call as an integration, right? The reverse process, right? If you have a function, now tell me, okay, now tell me for this one. Okay, now tell me this example, right? You have a function y is equal to, right? Okay, definitely you can accept this type of questions for your final exams, right? Okay, just think about 2x squared plus 5x into 7x cube plus 2x, right? This is y. This is a function, right? Now I am asking you, right? Now I am asking you, it's a little bit confusing for you, right? So maybe we will look at later those things, right? Just look at here. You have a function, right? 20x to the power 4 minus 3x to the power 3 plus 2x to the power 2 plus 5x. Just imagine this is a function, right? Now I am asking you, if I integrate one something, let's say this is dx, right? 80x cube minus 9x squared plus 4x plus 5, right? Now if I integrate this one, tell me what is the answer. Hmm? So how you can find out the answer for this type of questions? Only you know the function. Even we didn't discuss about integration, right? Only you know differentiation. So just first differentiate this equation. So dy over dx is equal to what? So 20 into 4, 80. 80 x to the power 4 minus 1 x to the power 3. 80 into x to the power 3 minus 3 into 3, 9x squared plus 4x plus 5, right? So this is the function I am giving you to integrate, right? So what is the answer? You can directly say y is the answer. So y means the answer is 20x to the power 4 minus 3x to the power 3 plus 2 into x to the power 2 plus 5x. This is the answer, right? So that's what I'm telling here. If you know the differentiation, the opposite process of differentiation we can call integration, right? Okay, another important thing I need to explain here, right? Just look at here. Okay, y is equal to, right, 3x to the power 4, right? So now tell me what is the dy over dx? Tell me dy over dx is equal to 12x to the power 3. 3 into 3 is a constant. So 3 into 4 into x minus 4 minus 1. X into 4 minus 1. 3 into 4, 12 x to the power 3. That is dy over dx, right? Now, based on the definition of integration, now if I integrate 12x to the power 3 by using dx, so what is the answer? 3x to the power 4. Okay. Now tell me another function y is equal to 3x to the power 4 plus 8. Tell me 3x to the power 4 plus 8. Now what is dy over dx? Tell me dy over dx is what? Just differentiate this equation, right? So dy over dx is equal to 12x to the power 4. If 8 is a constant value, right? Even if I differentiate 8, I am getting the same answer, right? Sorry, here I am getting 12 8 to the power 4 minus 1, 3. So this is 0, right? It means the same answer, 12 8 12 into x to the power 3, right? Now tell me, if I differentiate 12x to the power 3 into dx, if I put 3x to the power 4 or 3x to the power 8, because this one also we are getting this one. Here, this one also getting only. So based on the definition of integration, we know, right? If you get the differentiation result, if you integrate, you are getting the differentiation function, right? Now just look at here, y is equal to 3x to the power 4 minus 5. So now dy over dx is equal to what? The same, 12x to the power 3, right? Now tell me, if I integrate, now you are in confusion, right? Now tell me, if I integrate 12x to the power 3 into dx, whether I can put which one? So if I integrate these three, if I put 3x to the power 4, or I put 3x to the power 4 plus 8, 3x to the power 4 minus 5. I'm confusing, right? So this one is not changed. The base, this is not change, right? But the constant value, we don't know what is the constant value exactly. if I differentiate, right? So you're confusing, right? So just look at here, right? If I integrate 12 into x to the power 3, maybe we know we are putting only, maybe we are putting this one or this one or this one. We have a confusion on that, right? Did you get my question? We don't know which one we are putting. So to overcome this problem, we are putting, if I integrate these, we are putting, right? The answer is 3x to the power 4 plus c, right? This c, we can say uh, integration constant. This one we can say integration constant. Here also we are putting 3x to the power 4 plus c. Here also we are putting 3x to the power 4 plus c. So maybe this c have, here this c becomes minus 5. Here this c becomes plus 8. Here this c becomes 0, right? We don't know what is the value, right? So always if you integrate anything, right? Just you are integrating the main things, then you are putting one c, right? That is definitely you need to mention that c is a integration constant, right? We can call integration constant, right? Why we are putting? To overcome these challenges, right? Because if you have a different functions, right? This is a different function, this is a different function, this is a different function. So if you integrate these three different functions, right, we are getting the same differentiation results, right? So if I integrate these, whether you are putting this one or this one or this one, that's a confusion, right? So to overcome these, just you are writing 3x to the power 4, then plus c. That c we can say integration constant, right? That is the important thing, right? Okay, another one or two rules we will look at and we will stop, right? Okay, I will explain only three rules, right? Then we will stop, right? The first rule, right? The first rule, let's say you have a you have a a is a constant, right? If you have a constant, if you differentiate this constant, right? You have a constant. If you differentiate this constant, right? You are getting, okay, the first rule, yeah, give me a minute. The first rule, a is a constant into f of x. So this is the function, right? This is a constant. This is a function, right? They are multiple by each other. A into f of x, right? If I integrate these two, right, I can write a. I can take a in outside a into f of x into dx. I can write this way. Just look at the example, right? You have a 5x squared. So you have a function 5x squared. So if I integrate this 5x squared, I can write 5 into integration of x squared into dx, right? This is the first rule, right? So wherever you look at multiplication of constant and the function, right, you can take the constant outside. So that is the first rule, right? The second rule, that's not a big deal, right? The second rule, if you have a function f of x plus or minus g of x, then if you differentiate these, sorry, if you integrate these, we can separately integrate f of x into dx plus or minus integration g of x into dx, right? This is the same thing, right? Separately differentiation. Here we are separately integrate. That's all, right? The third rule, right? The third rule, let's say I will give an example for this one as well, right? Example, integrate x squared plus 5x. So this is two functions are get the summation, right? I can write integration x squared into dx plus integration 5x into dx, right? Now, if I apply the first rule, if you have a 5x, you can write this one as a this way, right? 5 into integration of x, right? This is the second rule, right? So the third rule, this is nothing, right? Okay, this is very, very important. Just look at here. Okay, if you have the function, you have a function x to the power n into dx, right? You have a function x to the power n. N is a number, right? If you if you integrate this x to the power n by using x, right? What will happen? X n to the power n x n x to the power n plus 1 over n plus 1 plus c, right? Just you need to remember this one, right? So if you have a function, if you have a function x to the power n, if you integrate this function x to the power n plus 1 over n plus 1, so this is, we can call integration of x to the power n, right? So this c we can call integration constant, right? Okay, now I will give an example. Just look at here, the example, right? I'm integrating x to the power 4 into dx. Okay, can you apply this theorem and tell me what is the answer? If I integrate x to the power 4, the answer is what? X to the power 4 plus 1, 5 over 5 plus c, right? So if I integrate x to the power 5 over 5, this is the answer for integration of x to the power 4, right? Now we will look at, we will validate. I already told you, right? If you have a function, then if you get the results of integration, if you get the results of integration, right? Right, the results of integration is what? X to the power 5 over 5, right? Now if I differentiate, this one, I am getting the results, right? Now just look at here. I already told you, right? I already told you, if you have a function f of x, right? If I differentiate this function f of dash x, again, if I integrate that function f of dash x, I'm getting the function of f of x, right? Now just look at here, right? Now I have a function f of x is equal to x to the power 5 minus 5, right? Now tell me, if I differentiate this function, what is the answer? If I differentiate, so 1 over 5 is a constant. Then I need to differentiate x to the power 5. So if I differentiate x to the power 5, 5 into x to the power 5 minus 1. So what is the answer? This 5 and this 1 we can remove. So x to the power 4, right? So if I differentiate this one, I am getting x to the power 4. So if I integrate this x to the power 4, I am getting this was the answer, right? This is my function. So this is if I integrate, if I differentiate, I am getting the answer of x to the power 5 over 5. If I differentiate, I am getting the answer of x to the power 4, right? So if I x to the power 4, if I integrate, I am getting the answer x to the power 5 over 5, right? So that the principle says x to the power n, if I integrate, what will happen? X to the power n plus 1 over n plus 1, right? That is the third rule, right? Okay, just tell me the example for this one, right? Integration x to the power, right? Maybe 2x to the power 7 into dx. So what is the answer for this? So 2 we can write in the in front of this, 2 into x to the power 7 into dx. Now tell me, 2 into x to the power 7, then how I can write if I integrate 7 plus 1, 2 into x to the power 8 over 8 plus c. So the answer is, if I cut this one and this one, 4. So the answer is 8 to x to the power 8 divided by 4 plus c, right? Okay, the next example, tell me, integrate, right, 2 to the power a to the power 7 dA, right? Now just okay, just think about, right, this way, right? 5a to the power 3, right? Now what will happen? This is my function. Now I can integrate by using a. So what will happen now? Hmm? I can write 5 integrate a to the power 3 into dA, right? Now I can write 5 into, so this is the based on the rule, right? So I can write a into 3 to the power 1 over 3 plus 1, right? So then what will happen? 5 over 4 into a to the power 4, right? Plus c. Don't forget to put the plus c. That is the integration constant, right? So we discussed three types. I will check this. There possible another one type. Okay. Yeah. This is the last type. Okay. The fourth type. I will stop with this fourth type. Okay. Just imagine you have a function of f of x, right? Okay. This format, right? You have a function ax plus b into, let's say, yeah, just imagine ax plus b, right? This is a linear equation, right? Now, if I integrate into dx, now what will happen? Now here to the power n is there. Okay, I will stop these three, right? It's enough, I think, right? It's already there are so many confusions, right? So now just you can remember these things, right? So if it's a constant, how you can do that, right? If you have a constant, how you can do that, right? If you have a multiplication of constant in a function, how you can do that, right? If you f of x plus g of x, how you can do that, right? Then the last one, if integration x to the power n into dx, we can write x to the power n plus 1 over n plus 1, right? These are the three different types we discuss in integration, right? So yeah, okay. Okay, I will explain one application and stop the class, right? One application, right? I already told you, right? If you have a function, right? If you have a function, this is a graph of the function, right? So this is x and this is y. I just imagine this is a function f of x, right? So now we need to find out the area of this one, right? So if it is a graph, that is not a different. This is not a standard shape, right? There are some curves, right? So from A to B, right? Now we need to find out the area of this. How you can find out this area, right? To find out the area, only thing you need to integrate this function f of x with dx from A to B, right? So if you find out this one, this is the area of this, right? Let's imagine, I explain with an example, right? Now I am telling you, okay, f of x is a function, right? The function is 7x to the power 4, right? Just think about this is a function, right? Okay, if it means this is a function, I'm asking you to find out the area from 2 to 3, or find out the area from 2 to 4, right? So now what I need to do here, right? Just the area to find out integration here 2 to 4 f of x into dx. So here f of x I can replace with 7x to the power 4, right? Now you know how to integrate this one. How to integrate this one? So a is equal to, so up to now just forget this one, right? This is a simple integration, right? So we can write 7 into integration of x to the power 4 into dx. Now tell me what is the answer for this 7 into, if I differentiate this one, x to the power 4 plus 1, 5 over 5 plus the constant, integration constant, right? So a is equal to 7 over 5 into x to the power 5, right? Plus c, right? Now what you need to do, they are already giving that range, right? The range is 2 to 4, right? Now what you need to do, if they are giving the range, right, here we need to put 4 and 2, right? So the meaning of this one, a is equal to, first you can replace 7 over 5 into, for x you can replace the uh, upper upper border, 4 to the power 5 minus 7 over 5 into 2 to the power 5, right? If you find out these two values, this is the area for this one, right? So the area is equal to 7 over 5. So 4 to the power 5 may be a big value minus 7 over 5, 2 to the power 5, 32. So if you get this is the area of that particular area, right? So this is the way we can find out the area with the help of integration, right? Not only this one, maybe we can find out volumes, and there are so many things of the applications as integration, right? So just you can remember only these things, right? If you integrate a constant, right? If you integrate a constant and a function, right? You can move that uh, constant in front of these, and you can define as an integration this way. If you have f of x plus or minus g of x separately, you can integrate, right? The only rule we are discuss, integrate x to the power n into dx, that is equal to x to the power n plus 1 over n plus 1 plus c, right? Then we are discuss the application, right? So application means if you have a function, right, you can find out the area of this function. To find out the area, just you can integrate the function, then you can replace with that particular range, right? That's all.